Hello, hello, hello. I hope everybody is doing good. We're going to have a flashback of the past tonight. We're going to go back to my second video. Will the real sun please stand up? It's the only thing I could think of to play. I'm getting red and yellow, so I hope this is coming through okay. You know, earlier today I was going through this shoebox of old cassette tapes and I found a recording of a band that I was in, and we played a Halloween gig at a place called Chaps. This is, I believe it was October 30th or 31st, 1999. So, I was in a band with three other guys. Jim was on bass, Mark was on drums, and Mark was something else. Well, you'll see just by hearing him talk. Good drummer, great singer. And a guy named Scott, what was his last name? Scott Yarrow was playing lead guitar. I won't bore you for long. I'll just play about 3 or 4 songs, and then we'll get into the video. All right? I want to hear it myself, and plus I thought I'd share it with you. The drums are going to be a little overbearing because he was an overbearing drummer, but he was good. All right. I'll see you in a little bit. It's good to see you. I hope that we have a nice night tonight. And let's have some fun.
Dude, you're gonna catch your fucking hair on fire. You're gonna catch your hair on fire.
Found an interesting article here. NASA pseudo-skeptic receives rebuttal from Electric Universe by Don Scott. Editor's note. On March 6th, I feel it.
First Beatles song. Love me do, I think it wasn't from there. Didn't take him long. Got himself a guitar, used to play every night. Now he's in a rock and roll outfit, and everything's alright. Don't you know? Johnny told his mama, hey mama, I'm going away. Gonna hit the big time, gonna be a big star someday. Mama came to the door, with a teardrop in her eye. Johnny said, don't cry, mama, smile and wave goodbye. Don't you know? Don't you know that you are a shooting star?
astronomers using NASA's Hubble Space Telescope watched a mysterious dark vortex on Neptune abruptly stare. Two more.
Hey, we got Kiss in the house. We're gonna do a little tribute to Kiss.
You know, and Kiss never looked better in their frickin' life, I'm telling you right now. I'm telling you.
Kiss is in the house.
It's so much better when a girl sticks out her tongue than a guy, I'll tell you that right now. Woo. Oh, we're gonna give it a shot. We don't really know this song, but you guys have inspired us. You've pumped something up inside, and we just want to frickin' try this song one time. So, Cold Gin!
cartoonist is an oldie from them. All right.
She come around.
Thank you. We're going to take a break. We'll be back here in 20 minutes.
Welcome to Cosmology 101, Episode 2. In this episode, we're going to take a look at both models of the Sun, the standard model versus the electric Sun. Without further ado, let's get started. Star birth. The standard model Sun birth, somewhere long ago and far away, an old star died, creating a supernova, which eventually became what we see as nebula. In this supernova, they say that all of the heavy elements that are on Earth were created and fused over a long period of time. This somehow, some way, became a swirling disk of dust and gas. The one thing that always bothered me about that theory is that if the star that died still had all this hydrogen left over to create one or more new baby stars, then why did it die in the first place? That has never really been addressed in anything that I've seen. So now we have a swirling disk of dust and gas. Then the remaining dust and gas that was left out of the star eventually, through what is known as accretion, became the other planets, which stuck together like little dust bunnies and all eventually became this planet. And then the collapsing nebula somehow ignited, and then it blew all the refuse out of the way, and what was left over was a solar system. And this star was born from the remains of the star that died. But there's that problem with, if there was all this hydrogen left over, why did the star die in the first place? And how did the hydrogen become perfectly placed out so that a family of stars could be born if more than one star was born at the same time? The standard model Sun. The Sun is a huge sphere of glowing gas. It produces energy and light, which make life on Earth possible. The temperature of the Sun varies tremendously, and not in ways that you might realize. At the core of the Sun, gravitational attraction produces immense pressure and temperature, which can reach more than 27 million degrees Fahrenheit, 15 million degrees Celsius. Hydrogen atoms get compressed and fused together to create helium. This process is called nuclear fusion. Nuclear fusion produces huge amounts of energy. The energy radiates outward to the Sun's surface, atmosphere, and beyond. From the core, energy moves to the radiative zone, where it bounces around for up to 1 million years before moving up to the convective zone, the upper layer of the Sun's interior. Now, this radiative zone has intrigued my interest, so I wanted to delve into it a little bit more. And it's also called radiation zone. Radiative zone is hypothetically a region or layer of a star's interior where energy is primarily transported toward the exterior by means of radiative diffusion and thermal conduction rather than by convection. Energy travels through the radiation zone in the form of electromagnetic radiation as photons. Matter in a radiation zone is so dense that photons can travel only a short distance before they are absorbed or scattered by another particle. gradually shifting to longer wavelength as they do so. For this reason, it takes an average of 171,000 years for gamma rays from the core of the sun to leave the radiation zone. Over this range, the temperature of the plasma drops from 15 million K near the core down to 1.5 million K at the base of the convection zone. In a radiation zone, the temperature gradient, the change in temperature as the function of the radius, is given by this math equation. I think it's worth noting that no other thing known contains a radiative zone in nature except stars. The temperature here drops significantly. Large bubbles of hot plasma form a soup of ionized atoms and move upwards to the photosphere. The temperature in the photosphere is about 10,000 degrees Fahrenheit. It is here that the sun's radiation is detected as visible light. Sunspots on the photosphere are cooler and darker than the surrounding area. At the center of big sunspots, the temperature can be as low as 7,300 degrees Fahrenheit, 4,000 degrees Celsius. I know astronomers like to use Kelvin. We won't. The chromosphere, the next layer of the sun's atmosphere, is a bit cooler at 7,800 degrees. Visible light from the chromosphere is usually too weak to be seen against the brighter photosphere. But during total solar eclipses, when the moon covers the photosphere, the chromosphere can be seen as a red rim around the sun. Temperatures rise dramatically in the corona, which can also only be seen during an eclipse, as plasma streams upward like points on a crown, which the word corona is Latin for crown. The corona can get to about 3.5 million degrees Fahrenheit. As the corona cools, losing heat and radiation, matter is blown off as a solar wind. The sun is the largest and most massive object in the solar system. It is about 93 million miles from Earth. The distance is called an astronomical unit, or 1 AU, and is used to measure distances throughout the solar system. The sun's light and heat takes about 8 minutes to reach us, which leads to another way to state the distance to the sun, about 8 light minutes. And that is the standard model of the sun.
Mainstream theory regards the cause of such granulation to originate from convection columns emanating from the solar interior. Jurgens was highly critical of the notion that violent convection from an exploding nuclear core can be observed in the photosphere of the sun.
The electric sun theory, or electric sun hypothesis, is the idea that the sun and stars derives the main source of their power electrically from its surroundings rather than from within by nuclear fusion. The mainstream view, which has never been duplicated by science on Earth. The electric sun is often attributed to a 1972 article by Ralph Jurgens, who acknowledges priority to a 1958 Melvin Cook monograph, an inspiration from Immanuel Velikovsky, Cosmos Without Gravitation, the electron sun theory, including Wal Thornhill and Don Scott. The electric sun model is a part of the electric universe theory and is being scientifically tested by the Sapphire Project. Where I'm going to read a synopsis from Wal Thornhill from his website, hollowscience.com. Plasma physicists argue that stars are formed by an electromagnetic pinch effect on a widely dispersed gas and dust. The pinch is created by the magnetic force between the parallel current filaments that are part of huge electric currents flowing inside a galaxy. It is far more effective than gravity in concentrating matter, and unlike gravity, it can remove excess angular momentum that tends to prevent collapse. Stars will form like beads on a wire until gravity takes over. The late Ralph Jurgens, an engineer from Flagstaff, Arizona in the 1970s, took the next mental leap to suggest that the electrical input doesn't stop there, and that stars are not thermonuclear engines. This is obvious when the sun is looked at from an electrical discharge perspective. The galactic currents that create the stars persist to power them. Stars behave as electrodes in a galactic glow discharge. Bright stars, like our sun, are great concentrated balls of lightning. The matter inside the stars becomes positively charged as electrons drift toward the surface. The resulting internal electrostatic forces prevent stars from collapsing gravitationally, and occasionally cause them to give birth by electrical fissioning to form companion stars and gas giant planets. Sudden brightening, or a nova outburst, marks such an event that elucidates why stars commonly have partners and why most of the giant planets so far detected closely orbit their parent star. Stellar evolution theory in the age of stars is an elaborate fiction. The appearance of a star is determined largely by its electrical environment and can change suddenly. Plasma physicists and electrical engineers are best able to recognize plasma discharge phenomena. Stellar physics is in the wrong hands. And that was Wal Thornhill on his hollowscience.com website. Just Google electric stars or electric universe. You see all kinds of hits that just pretty much show that mainstream is in some kind of a panic to go out of their way to say that this has been debunked and that it's just a bunch of hooey, when they are acting in what appears to me to be a state of fear. That really shows that it really needs to be looked into more in depth, because if it was something that they were not worried about, they would not be in such a panic to put all this mental pollution on the internet to try to hide the real story. That's just my opinion.
The standard solar model, this is the culprit. Arthur Eddington deduced the nuclear energy concept of stars. He based it on a number of premises, all of which were false, and yet he had the temerity to say it should not be too difficult to understand such a simple thing as a star. He used gravity and simple gas laws applicable on Earth but not in the solar plasma, which resulted in a simplistic model that took no account of the observed complexities of the sun. It is an impossible solar model because the coronal temperature is in the millions of degrees, the chromosphere is 10,000, photosphere 5,700, and the core requires a temperature of the order of 15 million degrees and an unreal density for hypothetical nuclear fusion. Even the nuclear fusion reactions cannot be tested, and in order to make it work, it involved quantum tunneling and all sorts of magical tricks to try and get a theory which would work. It was very clever, but is it real? It also needs a radiative zone unknown inside any other hot body. That had to be put in, of course, because you've got intense X-rays coming from a 15 million degree core, and somehow that had to be converted into just heat and light at the surface. Here's Ralph Jurgens. You've seen him before, some of you. He presented in the 70s, 1972, a gas discharge model of the sun. He wrote, "The modern astrophysical concept that ascribes the sun's energy to thermonuclear reactions deep in the solar interior is contradicted by nearly every observable aspect of the sun." I was inspired when I read his article. He provided a detailed gas discharge model applicable to all stars, a single model for all stars. This is quite distinct from modern cosmology, which has a separate theory for every star. So electric stars, like the lights of a great city at night, stars are lit at great distances from where their power is being generated. Each star forms the focus of a Z-pinch in the current stream. An electric star, for stars like the sun, the current flows in dark mode, so we don't see the spectacular glow mode bipolar wiring harnesses of supernovae and planetary nebulae. But every star has this form in its current feed system. Then how do we look at the sun within the heliosphere? Because these plasma sheaths, or the heliosphere, protects what's inside from the electrical environment outside. Most of the voltage that drives the sun occurs out at that distant boundary. This is why the spacecraft that are traversing that region at present are suffering so many surprises, because nothing's behaving the way they expected. They thought it was just a collisional boundary. It's not. Most of the voltage that drives the sun occurs across that thin boundary, and the result is, as Ralph Jurgens suggested, it's the origin of most of the cosmic rays in our galaxy. Every star has this cosmic ray accelerator at the boundary of its heliosphere. It's called the virtual cathode because if the sun forms the anode here, and it's just a coronal discharge into thin air, thin vacuum, there is a virtual cathode set up by the plasma. It's the boundary of the sun's electrical influence. It is the virtual cathode in the stellar corona discharge, and most of the sun's driving voltage appears across the plasma sheath. A very important point, because all of those who've, the pseudo-skeptics I call them, who attack this model, say, where are all the relativistic electrons streaming past the Earth? You know, we should see them. The point is, if you'll notice, that this here is the voltage gradient through most of the heliosphere. The only place where you'll see swift changes in that voltage gradient is at the virtual cathode. You'll notice the size of it here, and this little blip when you get into the corona. That's the thing that accelerates the particles in the corona and heats them to 20 million degrees. Cosmology and the electric universe can inspire, in my opinion, a scientific revolution of unparalleled scope. We see on the left there a planetary nebula and a plasma discharge tube, just as an example of the similarities. And they hinge on one simple question in both cases, plasma cosmology and the electric universe: does electricity play a role in the universe? The electric universe cosmology, a guiding principle of this is convergence of all human knowledge. This is why I've been associated with David Talbot and the comparative mythologists, because that extends our knowledge right back into prehistory. And when you think about the short time that we've been observing the skies with modern instruments, it's a very narrow view of the history of the skies. We do not want merely a modern consensus in one single specialized field. What is plasma? Moving plasma generates electric currents and forms current sheets, filaments, and bubbles. It produces radiation over large parts of the electromagnetic spectrum, and this makes radio astronomy extremely important in the future. There's already sufficient information to be able to overturn, in my opinion, all of the nonsense about the Big Bang available from radio astronomical observations. Interestingly, plasma behaviour is extremely complex, far more than I ever imagined. As I say here, the flow of electricity through plasma can cause glows, arcs, jets, filaments, beads, bubbles, kinks, sausages, tornadoes and explosions. That's a pretty fair range of phenomena to be going on with a single mechanism. It's just as we see in the lab, and as it turns out, it's just as we see in deep space. Of course, this has been mentioned, the electric force is 10 to the 39 or 10 to the 40 times stronger than gravity. And one of the scientists who was involved with the Velikovsky story early in the piece, Dr. Earl Milton, wrote an article called "The Gravitational Force is Zero," and he used this little example at the bottom. Gravitational force divided by the electric force is 10 to the minus 39, which is as good as zero as you can get. So we cannot ignore the electric force in the universe. In a plasma universe, we have to ask what physics lies behind these wonderfully mysterious objects that shine in deep space. All these glorious photographs we get from space are being viewed and interpreted by people who have no experience in plasma physics. It's obvious that energy has been supplied to the thin gas in space so that some atoms become ionized and glow. Astronomers are restricted to explosions to deliver the energy to this ionized gas. And in some cases, the distance between the glowing envelope and the central object that's supposed to have exploded precludes the explosion being responsible for the energy that we see radiated by these spectacular planetary nebulae. So the plasma universe can be far more complex than we ever imagined, while the underlying principles are very simple. And this may be chiseled in rocks on the surrounding country, out in the surrounding countryside near Los Alamos. Christian Birkeland is one of the electric universe pioneers. He was a Nobel Prize nominee and a pioneer. He built a model electromagnetic Earth, his Torella experiment, to mimic an aurora. And a good book about his life is by Lucy Jago called The Northern Lights. It's a good read. The thing is that this Torella needs electric power to work. So the phenomena we see in his experiments has to be powered electrically externally. And this is important, of course. He wrote, "It seems to be a natural consequence of our points of view to assume that the whole of space is filled with electrons and flying electric ions of all kinds." He was rather prescient in his statements. There's more to come. These magnetic field, the ambient magnetic field, which you can see here, are named after him, and it is the force-free means of transferring electrical power from one part of the universe to the other. The current filaments naturally form double helix or twisted pairs at every scale, from the laboratory to galaxies. And that's due in part to the difference in mass of the positively charged particles that carry the current and the negative, of course, the electrons that carry the current. It's interesting how these small differences here and there account for the complexity. So in deep space we have cosmic power lines. The electrical power transmission lines in space are usually in dark discharge mode. In other words, they can't be seen. However, they can be traced by radio astronomers. That's why I say radio astronomy is extremely important. Birkeland currents are to be found on all scales, from the lab to the galactic cluster, and can be detected by their magnetic fields. So like birds on a power line, we're unaware of the energy coursing past us so far. This is an experiment I did in Melbourne at the laboratories of the major telecommunications carrier with high voltage equipment. That red insulation is wrapped around a very heavy gauge copper pipe, and it's connected via this rod, which I'll show you in action in a moment. It's going to close the circuit between those two conducting balls you can see there. And this this is the result. It's compressed in both radially and longitudinally. It came down very hot. I had to toss it around until it cooled. And here we see an example in space of the very same effect. We're looking down the barrel there of a planetary nebula. This is an example of the electromagnetic pinch. It's also called the Bennett pinch. And you'll see here three examples. One, the laboratory example, the Southern Crab Nebula in the centre, and supernova 1987A, which is one of my favourite objects, since it shows all of the phenomena we would expect from a plasma pinch effect in space, and suggests that supernovae have nothing to do with an internally generated explosion in a star. Alfvén had an article published in the Boston Globe, I think it was in the 60s, and it was under the heading of Alfvén's Electric Universe. But one of the important statements he made was important fields of research, for example, the treatment of the state in interstellar regions, including the formation of stars, are still based on a neglect of Bennett's discovery, that's the pinch effect, more than half a century ago. Present-day students in astrophysics hear nothing about it. He said that in 1986. Starbirth. One of the features of an intense lightning bolt is that the current can actually pinch off totally so that it forms bright beads or plasmoids. So bead lightning appears with a particularly powerful fork lightning. It looks like the lightning discharge channel has broken up into a string of glowing plasma beads. So last year there was a report from the Herschel Space Telescope, which is looking in infrared into the birthplaces of stars. And here's a quote from the paper. A view of an incredible network of filamentary structures and features indicating a chain of near-simultaneous star formation events glittering like strings of pearls deep in our galaxy. That is, in effect, bead lightning in an interstellar cloud. There was a subsequent paper which examined some of these filaments in more detail, and here's the quotes from that paper. The filaments are huge, stretching for tens of light years, and regardless of the length or density of a filament, the width is always roughly the same. That's like cloud-to-cloud lightning. But the explanation of the astronomers is that all of these kinks in that are caused by exploding stars. So I asked the question, where are these exploding stars? And shouldn't there be some sort of radial curvature associated with those filaments? Instead of that, it has the same kind of tortured path of lightning. And the stars form along those filaments. An important aspect of the formation of stars and of all condensed bodies in the universe is this effect that occurs in a Birkeland current filament, and that is that it scavenges very efficiently widely scattered material and draws it into the central axis of the Birkeland current filament. Now the interesting thing is that in the standard model of the collapse of the protostar material, it's all radial, and astronomers have cooked up a story whereby the final collapse of all that material is adiabatic. In other words, there's no heat escape. Because the material here is distributed along that filament, the coolest part of the matter here is along the axis. And the other very important aspect of Markland convection is that all of the cool, low ionization potential elements, which you can see there are carbon, sulfur, iron, silicon and magnesium, all the things you need to make up a planetary core, are deposited along that filament at the axis. Of course, once you've got sufficient material along that axis, there is a tendency for it to break up into blobs or into stars. So this means that they must constitute the core matter of stars, not hydrogen. You'll notice that hydrogen and helium are on the outer rim of that Birkeland filament. So this destroys any idea that stars have hydrogen cores. Another tries to find these hotspots, they call them, 0.03 light years away from Earth, because they must be within that distance actually, because further out galactic magnetic fields should deflect the particles and smear them across the sky. So here we have evidence for another of Alfvén's predictions. Of course, no such sources are known to exist conventionally. I believe, this is my diagram, the electric sun has been confirmed because last year we heard stories about these energetic neutral atoms which are entering the heliosphere. This is the heliosphere, the sun's this little speck in the middle, and the current that flows in the equatorial plane of the sun, it may not be equatorial actually because these are aligned with the local magnetic field as you would expect from Birkeland currents. And here are the double layers that I've drawn in here, the cosmic ray accelerators. So the Earth orbiting in here will experience cosmic rays from here and from here, which is what's been found. This discovery of energetic neutral atoms in a ribbon around the sun, around the solar system at some unknown distance, was a complete and total surprise. There was no explanation for it. The other thing is that the particles come in from bright spots. Now, these columns here are actually a cylinder of Birkeland filaments. So you'll find bright spots where some of those Birkeland filaments are distributed around this cylinder. If you can imagine, that's a cylinder of electric current from the local industry currently. So, in my opinion, we have confirmation of the electric sun and its connection to the interstellar circuit.
It's really hard to gather a source for the electric universe's version of the sun because there are quite a few very good ones. I won't cite Don Scott as a source, I will just let you watch him. But I saw a description on the Thunderbolt site from a guy named Stephen Smith. It sums it up pretty good, so I'm going to read what he wrote. The electric sun theory presupposes that sunspots, flares, coronal heating, and coronal mass ejections are due to changes in the sun's galactic electrical supply. The contention is that the sun is powered externally and is not a fusion reactor. Instead, Birkeland current filaments, named after Christian Birkeland, carry electricity through the Milky Way, supplying the sun with variable power. The circuits in which Birkeland currents circulate generate magnetic fields, so their helical shape is known, since it can be seen. Plasma's behavior is driven by conditions in those circuits. Fluctuations in current flow form double layers with enormous voltages between them. This means that electric forces in double layers can be several orders of magnitude stronger than gravity. Double layers separate plasma into cells that can have different temperatures or densities. According to a recent press release, heliophysics, using data from the Solar Dynamics Observatory and the Big Bear Solar Observatory in the San Bernardino Mountains of California, think a method for supplying some heat to the solar corona was identified in their observations. One astronomer said, "We see certain kinds of solar seismic waves channeling upwards into the lower atmosphere, called the chromosphere, and from there into the corona." In the electric universe, rather than electromagnetism acting like railroad tracks, guiding the waves as they move up through the atmosphere, plasma discharge behavior is the best model for solar activity. It means seeing rotating discharge columns in profile. Electric discharges in plasma form hollow tendrils. Their centers are dark where convection cells would appear darker at their edges. The fact that sunspots have darker and cooler regions means that the sun is cooler in its interior. Another way in which conventional thinking differs from electric universe proposals is that most heliophysicists see the sun as a giant amplifier, accelerating solar plasmas into space in the same way that sound waves travel through the acoustical waveguides. As mentioned, however, it is spicules, rising thousands of miles up in the photosphere, that carry ionized plasma with them. Since the sun is the locus of positive charge with respect to interstellar plasma, sunspots appear when electric discharges penetrate the photosphere, allowing the electric charge to flow into its depths. Electromagnetic flux tubes, sunspot filaments, expose the sun's cooler interior. The idea of kinetic heat transfer from the sun's core cannot be supported by any observations. Multiple loops and arches connect sunspots and rise up from the photosphere, penetrating the chromosphere. The chromosphere is a plasma sheath, or double layer region of the sun, where most of its electrical energy is contained. When electric charge flowing into the sun's plasma sheath increases beyond a critical threshold, it triggers sudden solar flares and prominence eruptions. Powerful electric fields generate secondary toroidal magnetic fields that surround the eruptions. When current grows too strong, the plasma double layer is destroyed, interrupting the charge flow and allowing stored electromagnetic energy to blast into space. Solar flares, therefore, can be thought of as solar lightning bursts. This underscores electric universe advocate Wal Thornhill's assertions, where he says, quote, "After 100 years of neglect, an electrical model of stars is just beginning to emerge. It is an engineer's view that offers a coherent understanding of our real place in the universe and practical insights for the future exploration of space. If the sun shines as an electric light plugged in to the electric universe, the objective tests become obvious. Perhaps, with real understanding of stars, we may reach childhood's end in the cosmos." End quote. And that was signed Stephen Smith, Thunderbolts Group.
Surface works very analogously to the way a PNP transistor works. And we'll see that briefly at least. Anyway, again, to state the obvious, we all probably know that the major three layers on the sun that are important, and if you come toward the sun in the order in which you see them, would be the corona, the chromosphere, and the photosphere. Now, the corona is perhaps the most beautiful thing in the sky. It is this colorful. Those are, of course, the same colors that we see in the aurora. And why? Because it's the same thing. It is plasma in the glow mode. And it is the same sort of stuff, helium, hydrogen, mostly hydrogen, excited electrically. Again, everything I say, please ask yourself, while I'm saying it, how does the Standard Model explain this? The Standard Model has no explanation for why a corona exists in the first place. If the sun is just a nuclear furnace like a wood stove, my wood stove doesn't glow like that. And so clearly, everything that we observe around the surface of the sun, including the corona, is electrical in nature. One other comment, and that is that you can't see anything in the night sky that isn't plasma. Oh yeah, 'cause I can see the moon. Yeah, but of course the moon is reflected sunlight, and sunlight is plasma. The sun, where all of light that we see, if you look at Jupiter through a telescope or Saturn or any of the planets, you're seeing reflected plasma light. And we'll talk about the photosphere and where all that light comes from in a minute. But the corona is a pretty big thing. It extends out about 3 solar radii if you look at half the width of that disk. And then do 1, 2, 3. It takes you out to about the corner of that picture, and you can see that's about the extent of the corona. So it's large. The sun is 865,000 kilometers across, I think, something like that. The chromosphere, the second layer going in, contains these spicules. And spicules, we've all heard, the pines of Rome. The spicules are the fountains of the sun, not the fountains of Rome. But anyway, they have certain characteristics. Those spicules are really towering fountains of electrons that come up out of the sun and then back into the sun again immediately. If our assumption is correct, Jurgen's assumption that the sun has a positive charge, those electrons, once spewed, are very quickly brought back into the sun again. That's what the spicules are. The photosphere is where the action is, and that's what we're going to be talking about mostly. The photosphere consists of these things that the astronomers called photospheric granules. A more proper name for them is anode tufts. The anode tufts consist of plasma in the arc mode. And I've heard all sorts, even one of my good friends thinks the sun is liquid hydrogen or something. It better be pretty hot liquid, because plasma in the arc mode puts out a horrific amount of power. And as a matter of fact, but I should say this, those granules come and go with time. They grow, they get bright, then they shrink and they go away. The power put out by the sun is really fantastic. That is to say, the radiation from the sun, every square inch of the sun's surface on average puts out 42,000 watts. If you can think of what about a square mile, it's not boiling anything. It's arc mode plasma. The temperature of those granules or tufts is about 6,000 Kelvin, which is pretty, you wouldn't want to spend your summer vacation there, but it's in relation to the temperature of the lower corona, which is 2 million Kelvin. It's a medium temperature. Anyway, there's a picture of the granules. That's a movie. If you look at it very carefully, you can see it moving. It's a real-time motion picture of the granules. If you keep your eye on one, especially near I think that white stuff in the center is a bunch of spicules coming up through, I don't know, but I think that's what it is. And you see them, they're all over the place. Let's see, yeah, where is it? There's some down here, there's some over here, up here, and of course a bunch of them here. If you keep your eyes on the granules themselves, you'll see them shrinking away to nothing. And the question is, why do they do that? Well, there's a typical sunspot. And you might say, well, what's a sunspot? Well, a sunspot's where the photospheric tufts are not. It's a region where the photospheric tufts don't exist. And so there's been a good deal of work done in the laboratory on anode tufts. And we'll talk some about that. The main focus, I would say, of Jurgen's sun model is an anode tuft. How does the anode tuft work? And that's one of the things I'd like to spend some time on this morning. There is, of course, the penumbra. That's that orange ring that you can see. The dark inner area is called the umbra. And the temperatures in the umbra have been measured at, well, just something north of 3,000 Kelvin. So the umbra obviously is much cooler than the normal spots. I'm sorry, the normal tufts, which are the yellow region around the outside there. Anyway, I said that Monty had sent me some interesting pictures from Sapphire. There is one. Now, the purple wine glass in the back is not real. Monty has not been drinking. That's just an aberration of the photograph. This was taken inside a bell jar, and he and his team have managed to actually create anode tufts. The center bright purple thing is a spherical, although it's distorted some by the shape of the bell jar. It's pretty spherical, and it's the anode, and riding on top of that anode are anode tufts. And so the major property of these anode tufts is that they're made up of positive charges. And as such, you can think to yourself, just basic knowledge of electricity, if those things are each one a group of positive charges, then they don't like each other. They're going to be repelling each other. And so you see they're quite evenly spaced over the surface of the sphere. And as you'll see in a minute, when Monty increases the current, he increases the number of tufts and he increases the brightness of the tufts, and finally they turn into something in the arc mode, just like we see on the surface of the sun. So, as I said before, I think I said before, the main basis of Jurgen's model is an analysis of those tufts. And so we're going to be thinking of traveling in a line, if you can visualize, from the purple surface there, the surface of the anode, up through the tuft, and then out beyond the tuft. And let's think, what would we expect to see there? I'll tell you what Jurgen's expected to see there, and I think it's exactly what Monty is seeing and is going to see in his Sapphire experiment. That's the famous double layer. You're going to hear people in here talk about double layers. Hannes Alfvén was famous for double layers. Irving Langmuir got the Nobel Prize for his work with double layers. That's a double layer. That's all it is. That is what it is. Why don't those positive charges and negative charges come together and neutralize each other? Why do they stay separate? Irving Langmuir found out, and that's why he got the Nobel Prize. And I've heard people decry that can't happen. It's what you're seeing. Don't believe your lying eyes. Believe me, I'm going to tell you what happened. No, that's what really happens. And that's a picture of what the penumbral filaments look like. And it's kind of interesting that I maintain, and you think of it yourself, the umbra is a place where there aren't any tufts. So if you look at a cross-section of this thing, you can see tufts. They're all pushing on each other. You know, the samurai warriors, they don't like each other. But when it comes to the edge of the place where there aren't any tufts, these guys don't have anything to hold them back. So they fall in. And you can see that's happening. The reason I say you can see it happening is concentrate on the circular ring right on the outside of the penumbra, right between the yellow and the, ochre colored areas. And you can see that the regular tufts, the yellow area, right near where the tufts are breaking away, are going outward. You see that? And the tufts in the penumbra are going inward. Sure, they hate each other. They're both positive groups of positive charge. They're elbowing each other. And so when the group that is not being held back by anything and just falls off, when it starts to flow, to move, it's still pushing on the other guys. The space is opening up, and so some fall in and some fall away. So I think that is proof, the fact that the yellow ones actually move outward while the other ones are moving inward. When space opens up for them to be able to move, shows that what you're seeing is an electric reaction. It's not a gravitational reaction. At least I maintain it's not. The analogy, of course, is the calving of icebergs. You got a glacier, and you got the ocean or wherever that water is out there, and these things eventually break loose and fall in. In this case, this guy that's falling, in the process of falling in, is not pushing on anything. So there's no tendency for the tufts, if you will, the potential icebergs that are in the wall of the glacier, there's no tendency for them to move away because nothing's pushing on them. Only gravity is pulling the one down that's falling in. This is not the case, so this is a partial analogy. It is sort of like, makes you think about what is happening on the sun. But on the sun, this guy that's falling is pushing back like crazy on the one that he just came away from, and he's moving back. It's going to increase in strength, and the plasma tufts are going to go into the arc mode. You will see the photosphere. There they are. They don't like each other. It's like a bunch of kabuki warriors pushing each other away. They're all positive. And they're all looking for advantage and not finding it. You might hear Monty's voice in the background if they have the audio on. He's increased the current. The tufts have begun to go into, I know whether it's a high glow mode or that's arc mode. You can see now, it's a better model that you can see the sunspots. Sunspots are where there are no tufts. There's something that he's got the excitation such that it looks like the chromosphere. That little black thing in the bottom, I guess, Michael can tell me whether, is that the spectroscopic probe or it's a probe of some sort. There's the corona. The ring around the outside is the cathode. And of course, in the sapphire model, you need a cathode. But in real space, of course, the cathode is a virtual cathode. But there's the corona. The reason that the corona there looks like it's only on one side is because the anode is closer to the cathode on that spot where you get the corona. If it were equally spaced, you'd see the corona all the way around. Sorry for the hokey ending.
Modern cosmology with the medieval church. I think we've suffered through the last century the demise of physics. I've recently come to the position that Stephen Hawking was right. Philosophy is dead. Ever since Kant claimed that the world we observe is all in the mind. Because following Kant and Einstein, modern physics has followed that same path, and it's also dead but won't lie down. I've recently read this book by David Harriman, I think his name is, called The Logical Leap, and it's about induction in physics. And he says the only means of knowledge is reasoning from observed facts, and that's been the story for me. The senses provide our only direct contact with reality. He goes on to say that induction is much more difficult and controversial than deduction, and why it is not reducible to the formalism of symbols, and that's particularly true on the path that I've taken. Deduction takes for granted the process of conceptualization. Induction is the conceptualization process itself in action. David Harriman goes on to say that a conceptual consciousness is an integrating mechanism and its product, knowledge, is an interconnected system, not a heap of propositions, which is largely how science is at present. And here's the man who taught me. I came across his book before I entered university. I was inspired by the approach, the logical leaps that Velikovsky took. I had never seen before. When I got to university, I spent a lot of time in the sociology shelves at the university library, just picking books at random about myths and legends from around the world. And I found that the stories were understandable. They tended to leap off the page at me, and I could see how they related to what Velikovsky had shown in his work. I believed that he had made a case that needed to be answered. One of the things he did do as well was to throw down the gauntlet to astronomers by saying that electromagnetism was involved in the celestial mechanism. But this was ignored by astronomers who simply said, his work disobeys Newton's laws and therefore we can ignore you. They never picked up the gauntlet. In my view, cosmology must be a coherent natural philosophy and there can be no exceptions. If there's an exception, there's a problem with your cosmology. At present, the Big Bang doesn't address any of the big issues, in my opinion. I consider it a hopeless cosmology. It must provide insights into every discipline, including life itself and the human condition. And I think this is extremely important and something that Velikovsky felt also was important for our long-term survival. However, modern specialised science is a hostile environment for such a quest. Now, we do have an alternative cosmology that is accepted by the IEEE, the largest professional organisation in the world. It is based on the work of several Nobel Prize winners over the last century, has many successful predictions to its name, and also challenges the Big Bang. This is why astronomers ignore it. However, it doesn't handle unsolved problems in basic, particle and stellar physics. And this is the area that the electric universe tries to address. It tries to tackle these fundamental problems and in doing so offers a breakthrough in understanding of ourselves and our place in the universe. The electric universe, I believe, is an attempt at a convergent, interdisciplinary cosmology. And the first thing to do is to get rid of some of the perpetrators of the demise of physics. In my view, science left the path of reason and objectivity in the early 1900s, and I'm sure I won't get much argument from the audience having sat through many very interesting talks at this conference. Einstein and his proponents bequeathed us, in my view, a disconnected, incoherent universe that simply cannot function or give rise to life. This is why so much magic has had to be invoked to try and make the theory fit the facts. And if the facts don't fit the theory, you can ignore them. Don Hodson, who I believe is a member of the NPA, has said everyone who takes relativity seriously believes in the reality of at least one direction in which one cannot point. And I thought that was a very succinct way of putting it. I also believe that E equals mc squared, whether you attribute it to Einstein or anyone else, is the best known and most misunderstood equation in science. In my view, the real meaning of E equals mc squared is that energy, mass and the speed of light are all properties of matter. Electromagnetic energy, in my view, is stored in the orbital substructure of subatomic particles and manifests as their mass. The orbital substructure picture was given to me by Ralph Sansbury back in about 1981. Therefore, the mass of a particle is a measure of how much energy is absorbed in deformation of a particle instead of its acceleration. This is an alternative way of looking at the particle accelerating experiments.
So Standard Model does not challenge the basic assumption. I have a few more things to add to that, but not much. The sun is a variable star. In X-rays, meaning there's no way to find out how long it will continue to shine, as it does. But there appears to be a mechanism in place that maintains its brightness and electrical output, in spite of its varying electrical environment. Plasma operates in what is called dark mode in many cases, but it, unlike dark matter or energy, can be detected by radio telescopes. Plasma is significantly defined as the fourth state of matter. But it is only because it was the last to be discovered. In actuality, it is the first state of matter. Plasma was termed by Irving Langmuir, who won the Nobel Prize, and he named it plasma because it reminded him of blood plasma and seemed alive. An example of plasma would be a fluorescent light or a flame, which needs some kind of starter to get it going. Then there's normal glow mode. There is another mode called arc mode, like in welding, which again needs to be started with an electrical difference, which drops when it begins to operate. At that point, the air breaks down to become a conductive plasma. And this thing called the pinch effect, it has been reproduced in laboratories because the beauty of the electric universe is that the plasma operates the same in tiny experiments or galactic interactions. The pinch effect of the electric current is what forms galaxies, and also within those galaxies create the stars. The pinch effect is powering the galaxy and then down to the stars, and then actually power the stars themselves with these things called anode tufts. Walt Thornhill has made an analogy that, seen from space, one might think that a bright city would be powered from within. But actually, it is being powered by invisible lines from power stations, sometimes hundreds of miles away. The sun works on this premise. Now, the solar wind, as it recedes from the sun, accelerates, and it is actually an electric current and not a wind. So it has been misnamed. But there is also a problem with the standard models missing neutrinos. As it is known, when you combine 4 hydrogen atoms in a nuclear reaction, they have to get what is called a neutrino. So there must be all of these neutrinos coming from the sun, but they're not finding them anywhere near the amount they need, which should be being generated at the core.
Compressed matter in the core of the sun to cause its thermal temperature to be around 15 million degrees. And that it's this pressure that is responsible for the nuclear reactions causing fusion, and that through various ways this energy migrates and finally escapes through the layers of the sun, creating the photosphere, which is cooler at about 6,000 degrees Celsius. And then further on out to the corona, where the temperature again rises up to around 2 million degrees. But this is one of many disparities that heliophysicists have spent years working on to discover. Why does the sun shine? Hurry if you would.
It's almost there.
Yeah, discharge to the stem, but it's fine. So we have these anodes we can throw out. And that was day 2. So we thought that was pretty cool too. We thought, okay, we've got some good news, and now we can go to the conference. And then
the spicules of the sun have to be investigated from a new vantage point, and so much of this has to do with the interfacial dynamics of different plasma regions and charged particles being launched into higher regions and so on. And both Don Scott and Walt Thornhill place a great emphasis on the study of the spicule dynamics.
Solar electrical effects. The sun's surface is carpeted with complex magnetic fields. Only electricity can produce magnetic fields, therefore the sun must be understood in terms of electric circuits. Where are these circuits and what creates them? And what sustains them? Plasma physicists know that the movement of different types of plasma past one another will generate currents in the plasma. When you get back to first causes, we do not know. We don't even know the right questions to ask at this stage of our ignorance, I would suggest. Sunspots are an embarrassment in the thermonuclear model. They have powerful magnetic fields with the same polarity spots clumped together. Now, normally the same polarity magnetic fields push one another apart. However, the magnetic field here is a signature of the Birkeland currents piercing the photosphere. And the pinch effect means the magnetic field is very intense in sunspots. They are drawn together because parallel currents attract. It's as simple as that. Ampere's law. Their darkness, structure and behaviour have required great ingenuity in attempts to explain them, yet they remain mysterious. I asked the question, does this sunspot penumbra, this is where you can see edge on to the photosphere and look deeper into the atmosphere, or the ionosphere, I should say, of the sun. And I asked this question, does this sunspot penumbra look like turbulent boiling hot gas? And I would say not. It has structure, it has a motion which doesn't look like boiling material coming up from the interior of the sun. And why is the sunspot dark if the sun is
Clyde said your message could not be delivered.
Because we're trying to get that.
This is usually because you don't share a server with the recipient, or the recipient is only accepting direct messages from friends. You can see the
simplest answer is that the sun is thousands of degrees cooler below. And remember I said stars are formed with cool cores? They're not formed with hot cores. They could never have any nuclear reactions in their core under those conditions.
Hi Greg, how are you?
This man was amazing. He wrote, it might be imagined that the interior of the sun formed a positive pole for...
Yeah, I'll just stay here, Gizzy, when you're ready.
This assumption has the advantage of appearing to give a natural explanation of the movement of the sunspots in various latitudes. This experiment has been repeated back in the 60s, and depending on the current input, those spots move in latitude, which is exactly what we see. So the sunspot movement across the latitudes on the sun is a measure of the changing input to the power input to the sun. In this case, he wrote, the origin of the sunspots must be that the presumptive, more or less insulating photospheric envelope was sometimes pierced by disruptive discharges. I couldn't believe it when I read that. Thus forming great electric arcs. I would say he was the first one to actually tell you what a sunspot is. And that was from his huge tomes called the Norwegian Aurora Polaris Expedition, published in 1902, 1903. What do we find today? This is the sun in ultraviolet light, and you can see that we have an equatorial view at the top and a polar view at the bottom. And it has a plasma torus about it, and this is exactly what Birkeland had found in his experiments, that you get a plasma torus, and it's a storage ring, it stores energy. When that energy gets to a certain level, a massive discharge will take place from that torus to the surface of the body, and it follows the magnetic field lines. In the extreme case, when there's too much energy in that ring, it may actually switch to a polar jet. Many stars have polar jets. I suggest that these long filaments in the penumbra are actually electrical tornadoes, thousands of kilometres long. They have bright edges, dark cores and a twisted appearance. And there's a special effects fire here with a helicopter engine above, and fire is injected at the bottom, and you can see the bright edges here and the dark core, and you can see these filaments here. It's exactly what they've got. And bright lightning flecks the tops of the granules. These are the solar granules that we see covering the sun. So the sunspot cycle, you see the sun in X-rays, and it is a variable star. It almost winks out at solar minimum, and at solar maximum it is much brighter. And X-rays are a direct measure of electrical activity. The sun is connected to a galactic circuit which is subject to quasi-cyclical change, so that the origin of the sunspot cycle is beyond the solar system. It may be due to Alfvén waves in the Birkeland currents that feed the solar system, or it could be due to the actual motion and rotary motion of the Birkeland currents past the heliosphere. Seen in X-rays, the Sun is a variable star, and yet the heat and light from the Sun is constant to within 1/10 of 1%. An explanation is very important, for it explains why most bright stars shine steadily. And it's not like the 4th of July. An electric sun, this is something that Don Scott pointed out, because he's an electrical engineer and knows this stuff inside out. He said this voltage curve here across the photospheric tufts, those long filaments that we saw a moment ago, is that of a PNP transistor. In other words, this tufted sheath of our sun forms a barrier for protons escaping the sun, because those protons trying to escape the sun have to climb this barrier here before they can go down this waterfall and excite the corona to its tens of millions of degrees temperatures. And beyond here, there's a slight electrical field, just enough to accelerate the solar wind the way we see it. Of course, this then is a regulating mechanism, because just a small shift in voltage up and down here is enough to modulate the power output that passes through these tufts. And that is the regulating mechanism for all bright stars that have a photosphere. That's why they shine steadily in the night sky. There is no regulating mechanism for a thermonuclear model star. In fact, they're the most unstable things you could imagine, because some of the reactions vary with temperature to the 5th power. Here are these strange things called spicules, and Ralph Jurgens didn't shrink from trying to explain these as well. And it turns out that to maintain a steady discharge through that tufted sheath, there has to be a balance between the number of electrons travelling in one direction and the number of positive ions going in the other. And these spicules actually provide the material to be ionised in the chromosphere and maintain a steady discharge. There's an analogue in some arc lamps, the kinds of things used in searchlights. They had porous anodes to actually produce this steady arc. Don Scott, this is his diagram from his book, The Electric Sky. It's the solar transformer. The greatest puzzle of the Sun, its magnetic field reversals, is solved. The Sun has magnetic fields induced by a varying DC power input, and so acts like a power transformer with an impressed DC current as well. So all you've got is a varying DC current which is driving the Sun. Remarkably, once again, here he is, Christian Birkeland proposed that solar magnetism was caused by electric currents induced in the conductive interior of the Sun. Hey presto. He should have got a Nobel Prize, several of them. Solar neutrinos match the no thermonuclear engine inside the Sun. It's not important, but it's just one of the questions that arise. The neutrinos produced in the dense photospheric plasma, because these are pinches, is where the nuclear synthesis takes place. So stars produce their own heavy elements. You don't have to have supernova explosions to do it. A supernova explosion actually distributes the material that the star has already formed. A neutrino count falls when the sunspots reduce the photospheric area. So the higher the number of sunspots, the lower the number of neutrinos, which is what you'd expect if this second point is correct. So we need not assume a change in flavour of neutrinos, whatever that means. In other words, a change in resonance state of the neutrino en route from the solar core, because the reactions in those plasma filaments is much more complex than the standard hydrogen to hydrogen chain reaction would provide. Now, stellar and planetary structure and composition are based upon the erroneous conviction that Newtonian big G is a universal constant. So when I say that this Sun has a heavy element core, of course the helioseismologists would say, but you know, our models show that it hasn't. But they're basing their model on a completely erroneous idea about the amount of matter in our star or any celestial body. If big G is a variable dependent upon the electrical state or the electrical tension in a body like the Sun, then we cannot say what it's made of. We have no way of knowing.
No, but it's okay.
material that comes from it. And if the sun is cool, there is a radial internal
Let it
to
finish.
be considered, because, as I said before, all the positive charges are heavier than the negative charges. So in a gravitational field, there would be an offset and a radial electric field, so all celestial bodies behave like electrets. These internal electric fields can actually respond to disturbances and cause the ejection of large quantities of core material. In other words, form planets and moons and so on. The electric sun has a completely different picture. Here we have a cool core. We have an extensive atmosphere and an ionosphere at the top, and at the very top of that ionosphere is this global lightning or electrical tornado system, packed cheek by jowl. Then above that you have the energy flow, and of course it's normal to expect that incoming electrical energy will excite the plasma out here first, and then as it gets into the more dense atmosphere it will exhibit discharge activity. Out here it's a coronal glow, in here it's normal electric arc phenomena. So the energy to heat the electric sun comes externally from the galaxy. The electric discharge becomes intense close to the sun, heating the thin atmosphere of the corona to millions of degrees, and the superheated corona is a familiar glow discharge phenomenon recognised by high voltage engineers. Now we come to the HR diagram. It's based on observations, it's not based on theory. It's a scatter plot, not an evolutionary plot, and the luminosity and colour of a star depends on its size and the current density at its radiating surface. Discontinuities exist. You've got white dwarfs over here, red giants here, and red and brown dwarfs, which are all discontinuous with the main sequence. These are all stars with bright photospheres, so they have that regulating mechanism. Of course, the astronomers got it back to front. If you do a mirror image, then you have a more understandable arrangement where the stars get brighter and bluer as you increase the current density, so that you get this straight line curve, which is exactly what you'd expect. Red stars have to expand. That's both red dwarfs and red giants. They're stars which are not collecting enough electricity to satisfy the discharge, so plasma adjusts. It's like a living thing almost. It adjusts to its environment. And so it expands the anode sheath to collect enough current. And some of those anode sheaths are monstrous. You know, Betelgeuse, if that star was in our solar system, its photosphere reaches out to the orbit of Jupiter. White dwarfs, on the other hand, may be normal-sized star, but they have no bright photosphere. Their upper atmosphere is in direct contact with the plasma of space. They have only a faint white corona. Imagine if the sun's photosphere turned off, you would see this white envelope, very faint, but very white, very high temperature in appearance. So stellar evolution is a fairy story. This is V838 Monocerotis. This erupting star transformed itself over a period of months from a small underluminous star, a little hotter than the sun, to a highly luminous, cooled supergiant star undergoing rapid and complex brightness changes. This was the quote of the article describing it. The transformation defies the conventional understanding of stellar life cycles. It's a very complex story. I've been through it, the theory of it. So here's a red giant. This is actually Betelgeuse. It's 500 times the size of the sun, and it has a hot spot. You've got to ask yourself, what's a hot spot doing on a red giant star? What happens is as that envelope expands, the electric field grows stronger because it's trying to collect electrons from space. But on the other hand, positively charged particles, in other words, its stellar wind, are accelerated more strongly the other way. So you have this anomaly where these cool stars have the most powerful winds known. And if the stellar wind is being boiled off, so to speak, this doesn't make any sense at all. Betelgeuse sports a hot spot. I've suggested it may be above one of its poles because one of the Alphane circuits shows that one of the connections of the electric circuit is to the poles of the star. So we may be staring at one of the poles. Giants and dwarfs. The usual story is that stars consume their fuel and change to giants or dwarfs. The story is complex, unverifiable, and regularly contradicted. This is another version of the HR diagram there. And astronomers are perpetually astonished by unexpected changes in stars. This is a white dwarf system. Sirius B is the white dwarf, and Sirius A, you'll see an optical light here. Sirius A is very bright in the sky, and Sirius B is almost invisible, and it's a faint white, so-called white dwarf. Now, if you look at it in X-rays, it's the reverse. Here's Sirius B, it's brighter than its optically bright partner Sirius A. This is what you'd expect, where the discharge reaches into the ionosphere directly of a star. The X-ray output is high, the visual light output is low. There's nothing special about that. It can be an ordinary star. It's just that its partner may have usurped most of the current. It's supposed to be a collapsed star at the end of its fuel. But how can an old and a young star be together? Because here you have an old and a young star, so to speak, under the conventional ideas, together. The white dwarf has no bright photosphere. Its white light and X-rays come from an intense corona. Here's the different star types, and I've shown how I think they would look. A red dwarf is actually quite large. In other words, it's like a red giant in miniature. A red dwarf was discovered, and the astronomers decided that it was putting out too much light for what they assumed was a dwarf star. So they said, oh, it must be a pair of red dwarfs of exactly the same size and power output. I suggested no, it's a single red dwarf. It's just much bigger than anyone ever expected. Main sequence star, it is covered with photospheric tufting, tufted anode and a controlled discharge. Blue giants are a large star under high electrical stress. Red giants are a normal star under low electrical stress, and it develops a glowing plasma sheath. A white dwarf is a normal star in direct contact with space plasma and has low luminosity. Talking about brown dwarfs, if a brown dwarf gets close to a very bright star, the bright star is at a higher potential than the brown dwarf. That brown dwarf will actually switch off as a star and become a comet. It switches from being an anode in the discharge system to being a cathode, and there are quite distinct differences. Now, if the Earth, hypothetically here, if the Earth was a satellite of a brown dwarf, that radiating shell would be quite enormous. You could have all of the satellites of that object, that small star, orbiting within that envelope. That whole radiating envelope puts energy on the surface of any orbiting planet equally on every square metre. So that you would have no seasons, no day and night, and you'd receive ultraviolet light. This refers to what Dwight was talking about the other day with the earliest memories of mankind. It suggests that we were in this situation, and astronomers in recent years have come to the conclusion that this is the more likely place for life to thrive. Where we are now is much more precarious. So brown dwarfs don't hang out with stars because electrically it's impossible. The other thing is that these brown dwarfs, unexpectedly, they flare. They throw material off occasionally because they've got no means of controlling their discharge other than to get rid of material, matter, charged matter. So that any satellites of these brown dwarfs gets occasionally drowned in water, an atmosphere, and also solid materials to cause layering on them. Brown dwarfs flare and deposit layered minerals on their satellites. There's a few more logical leaps involved in the electric universe, and I'll just go through a few of them. I asked the question, is gravity a weak electric dipole-to-dipole force between distorted subatomic particles? And this refers to something that Velikovsky said to me when I visited him, and also to Ralph Sansbury's view that all subatomic particles have an orbital structure, a resonant orbital structure. And as Ralph has pointed out, magnetism then is also an electric dipole-to-dipole force due to transverse distortion of electrons or protons accelerated in an electric field. If so, the electric force is the only force necessary in physics, and this goes back to the way classical physics operated, by trying to reduce the number of forces and ideas. And quantum effects imply that all matter has a resonant electrical substructure. information and energy can be stored and transferred via these matter resonances, and that has significance in biological systems too. So astrophysical and biological coherence requires universal, near instantaneous electrical interactions. All of the so-called spooky quantum things are no longer spooky if we accept this idea. We have a return of the ether. We must have particles to be able to transfer the energy and the forces through so-called empty space. Empty space, I suggest, is full of neutrinos. Neutrinos are the lowest energy state of matter. They exhibit a vanishingly small mass. They're composed of subtrons, which is what Ralph called them. They form electric dipoles, that is the neutrinos, in an electric field, and each dipole rotates in the electromagnetic field of a light wave. That ties the speed of light in a vacuum to the moment of inertia of a neutrino. And neutrinos may reintroduce cause and effect to radioactive decay. At present, it's a purely statistical phenomenon. The other thing is that it also solves the difficulty of the so-called annihilation and creation of matter in particle accelerators. You cannot do it, but if the neutrinos are the substrate, they can accept energy and become a particle and its mirror particle. I don't use the word antiparticle because there's no such thing. It's all matter, normal matter. I put these few slides on the end because there was discussion about Venus and the transfer of charge, and I think it's important because it returns Velikovsky's gauntlet to him cordially. Velikovsky argued that planets change orbits, exchange thunderbolts, and quickly settle into peaceful orbits. Now, rapid settling after chaos defies Newton's laws, which, of course, that was the argument levelled against Velikovsky, which for more than a two-body gravitational system are chaotic anyway. So the astronomers have yet to explain why we have a stable solar system. So astronomers simply ignored the gauntlet flung down by Velikovsky. Then we have Anthony Peratt and the convergence of his work with ours some few years ago. And he showed, globally, petroglyphs show to a high degree of confidence that within human existence the Earth has suffered stupendous electric discharge phenomena from the heavens. And that's a picture of one of his papers. Now, if we accept Velikovsky's gauntlet, we need to look at Newton's law of gravity again and just have a think about what it really means. You'll notice there that G, I put its dimensions there just to show that it does include mass. And if mass is a variable, then we have a problem. It is simply assumed that G is the same for all bodies in the universe. In other words, the universal gravitational constant, and that was an assumption. Stellar and planetary structure and composition is based upon this premise, but if mass is a variable, can it explain cosmic pool? The book over there is by one of the Thunderbolts team, C.J. Ransom, The Age of Velikovsky. Of course, MOND is the latest buzzword in gravity theory, the modified Newton's dynamics. I've suggested that we can have electrically modified Newtonian dynamics. And I won't go through all that business there, you can see it on my website and so on. But the upshot is that the radius of the orbit of the planet is proportional to the mass of the planet if you keep the orbital energy constant and you assume the sun's G is constant, and I think that's a fair assumption. If the mass doubles, the orbital radius must double to conserve orbital energy. Now, I said earlier that all planets and stars and all celestial objects will form an electret. In other words, you have positive poles facing inwards and negative poles facing outwards. So it sets up an internal electric field. The planet acts like an electret. And any free electrons would tend to drift towards the surface. Like a subatomic particle under the stress of an electric field, the internal electrical stress modifies the apparent mass of the planet or star, and therefore its gravity. Exchanging charge at the surface through lightning, etc., changes the mass or gravity of a planet. And there is evidence for that. Coronal mass ejections, large ones which strike the Earth, actually change the rate of spin of the Earth suddenly, and then it decays back to its original speed, which is diagnostic of a change of the moment of inertia of the Earth by some means which hasn't been explained. Comet accelerations also. Cometary displays are an obvious electric discharge phenomenon. Any body on an eccentric orbit about the Sun will experience discharge activity. The discharge will cause apparent non-Newtonian acceleration, and this is well known with comets. They're very hard to predict their precise return because of them. And this is because the mass of the comet is changing, something that's not taken into any account. However, gravity is still the operative force, but here we have a feedback mechanism which can modify orbits. So, changing planetary mass. The closer the encounter between two planets and the more powerful the charge exchange between planets, the greater the orbital adjustments. It seems an efficient mechanism for collision avoidance and spacing the planetary orbits apart, which may explain one of the reasons why we survived Velikovsky's catastrophic scenario. The inner planet reduces its charge polarization, its mass, and the outer planet increases its polarization, mass, in the exchange. And I ask the question, is this possible? Yes, I believe it is. Because some years ago it was reported that a spacecraft here, the SOHO spacecraft, picked up stringy things, stringy plasma things, arriving from Venus when it was between us and the Sun. Now those stringy things, of course, are recognised immediately as Birkeland currents, and the Birkeland currents transfer electrons from Venus to the Earth. At present it has little or no effect on the Earth because of the distance and the low current density. So there's an intermittent circuit for transferring electrons from the inner planet to the outer when they're aligned with the Sun. The charge transfer is in the correct sense to induce the planets to move apart into orbits having electrical least interaction. Quickly it will appear as though the system operates according to Newton's laws with no sign of recent instability, and that was the problem that Velikovsky faced, and it was the question I asked him when I visited him. How do we deal with this problem? And I think this is the answer, or part of the answer. And we come to the Sagnac Award winner, and I consider a great man, a modern Galileo. Dr. Halton Arp embraces a plasma universe. I think it's a very apt photograph. Also, I might say there are a lot of interesting issues raised by Halton Arp's discoveries that fit neatly in an electric universe solution. For example, intrinsic quantized redshift and an increase of mass with time are explained by an electrical origin for particle masses and their resonant quantized states. Because the quasars are ejected from a galaxy, the electrons are tangled up in the plasmoid at the centre of a galaxy for far longer than the neutrons, which can escape because they're uncharged, and the protons, which are heavier. So that quasars are electron deficient initially, which means that all of their energy levels of all their matter will function at a lower level. Their fine structure constant will be different. Their redshift spectrum will be enhanced. But over time, as the electrons stream out in those great jets that we see, both the mass increases, but it does so in resonant steps, quantized steps, and the brightness increases because the electrical energy arriving is increasing. And so this explains this very strange phenomenon where a quasar ejected at very high speeds from the centre of an active galaxy can actually slow down and go into orbit about its parent. So this is the quasar mass gain. You can see this is one of Arp's diagrams of the birth and the development of quasars into companion galaxies. Intrinsic redshift, an increase in mass of subatomic particles equals an increase in the orbital energies of electrons within atoms in the quasar. That results in a decrease in redshift of the quasar. And since subatomic particles are resonant systems of charge, the redshift must decrease in quantum jumps. Now, any explanation for this kind of intrinsic redshift gets over the problems that you face if you try to talk about the medium between us and the quasar, because you cannot quantize, as far as I can imagine, the redshift by anything that occurs between us and the emitting object, but it's intrinsic to the emitting object.
Called the scientific establishment rose in
All right, I was waiting for Walt to finish out of respect for him. I didn't realize that I recorded so much of that, but how can you turn it off? You know, he's spitting knowledge, everything he says. So for me, it was really hard to figure when to cut that off, you know. And I just wanted to come out and say hello to everyone. Grouch, are you there? Grouchy. Wait a minute. Grouch, are you there?
Yeah, I'm here.
Oh, okay. I had.
Patiently.
Did I have the right mic on, or I don't know if I got? Okay, I think I got. Yeah.
I could hear you.
You can hear me? Okay.
I could hear you.
Yeah.
Yeah.
How am I coming
Yeah.
out?
So I could
there?
hear everything you were saying.
You guys hear me okay? Yeah, it's hard to turn wall off. Isn't that awesome? I mean, every time I never get sick of it. I just, you got, oh wow. It's really cool watching. And this was recorded I think in 2005. So just imagine how much, we've learned since then. But man, sooner or later, they're going to have to come to grips with the fact that the universe is electric. Bob Hall. I know I ain't popular or welcome here. I believe the Bible is the communication we were given. Religion is the biggest F job ever perpetrated on humanity. Well, yeah, you're entitled to your opinion, Bob. We got a lot of opinionated people here, and I don't think anybody would take it personal. That someone might want to debate with you, but that's healthy. You know, there's nothing wrong with that. But I don't know what it broke. I do believe that the electric universe theory says we don't know how we began. They're not afraid to say that. So we got Renegade, we got Buried Axeblade. Oh, I love you two guys. That's why you're blue. We got Bob Hall. And we got St. Pauli Girl. Yeah! St. Pauli Girl, come and join us. And we can talk about it. I mean, when he talks, doesn't it make sense? It's just, I mean, wow. You know, there's one thing I want to know though. Okay, so the sun is a positive body. Right? The sun is a positive body. Okay. Now, for every positive ion that it sends out, it takes in a negative electron. Okay? So that must mean either there's electrons going toward the sun, or perhaps the sun's magnetic sphere is negative, and that's where it gets fed its negative ions. Because there has to be a steady stream of negative electrons going into the sun. That's one thing I've wanted to ask someone who would be in the know. What's going on there? You know, for every electron, there has to be a positive ion. Circlek, what's going on, buddy? Good to see you. Very good to see you. We got 56. I don't want to talk too long because when I talk, I tend to lose viewers. So we're probably going to get back to this. And I think next we'll show 3, and then we're going to have a little chat, hopefully. After this is over with, because it's only got like 10 minutes left. When this is over with, we'll have a little chat about it, and then we'll go into the next one. So I'd like for Grouch and Alchemy 88, yeah! Grouch and St. Pauli Girl, because someone wanted me to talk to you about the electric universe. So if you're there, please come here. And we'll finish this video right now, and then we'll get on with the rest.
Greg, that was good music at the start too.
Oh yeah, that was my band. We called ourselves the Pygmy Bush Babies.
All right.
Yeah.
I wouldn't have. I thought the drummer was pretty good. He did what most drummers do, made a lot of noise.
Oh yeah, but
he was good.
He was.
And you could still hear the words.
Yeah. Did you hear my singing?
Yeah.
I sang American.
Yeah.
Sang Gloria and played the harp.
Mm.
Although I miss those days sometimes, but I don't miss the back.
Hey, man.
I was the guy who wheeled everything in and set everything up, did the sound, did the lights. The other guys just showed up and played, you know. But that was. I've always kind of been a control freak, I guess. I got to be the leader, you know. I don't know.
Yeah.
But in that band, I really wasn't. It was a democracy. Everybody, those guys were such virtuosos at their instruments. All I had to do was sing and play rhythm guitar, you know. That was cool. I loved
Yeah.
that.
Oh, well, if you got more, if you got more from when you did that,
oh sure,
we'll listen to it.
Yeah, I just don't want to bore people to tears, but yeah, I'll play. I don't mind playing. I'm kind of proud of that band. All right, well, I'm
I
gonna
suppose
get
the
back.
only way is they'll tell us in the chat if they're not happy.
See, we got our own Ozzy here on the Greg J channel. That's right. All right, hang tight.
Catch up.
Let's watch the next 10 minutes of this.
All right. See ya.
Okay, Greg.
Arms not only against the new Velikovsky theories, but against the man himself. Efforts were made to block the dissemination of Dr. Velikovsky's ideas and to even punish supporters of his investigations. Universities, scientific societies, publishing houses, and popular press were approached and threatened. Social pressures and professional sanctions were invoked to control public opinion. There can be little doubt that in a totalitarian society, not only would Dr. Velikovsky's reputation have been at stake, but also his right to pursue his inquiry, and perhaps even his personal affairs. And that's absolutely factual. And one of the major scientists that was put onto the case of Velikovsky to totally try to refute all of his theories was none other than Carl Sagan. That was Carl Sagan's evening job, if you will, was to go around and harass and try to refute all the theories of Immanuel Velikovsky, and he was not able to refute any of them. Alfred A. Wallace, no less the co-founder, who discovered natural selection previous to Darwin, and with him was the founder of the evolutionist theory. But on reviewing the startling differences between Homo sapiens and other mammals, he realized that man was an exception to the rules of evolution. He amazingly wrote, "Some intelligent power has guided or determined the development of man."
There are so many things that mainstream science does not know. For example, they don't know what gravity is. They can't define it. What makes that happen? What is it that makes the Earth spin? What is it that holds thousands of tons of water in the clouds before a rainstorm? It should just pass right through it. Why is the surface of the Earth negatively charged? Why is it that negative ions are healthy? These fundamental questions, modern mainstream science just doesn't even really bother to know the answers. They just avoid the question or accuse you of being a conspiracy theorist for even asking.
And by the way, this is called gravity.
The electric universe can tell you these things. You get a negative charge, it is healthy. So that must mean that our bodies are negatively charged, like the Earth. The electric universe is a very broad, high-altitude perspective. One has to really put aside all of the dogma and teachings that have been pounded in them since childhood in order to take a true, unbiased look into things. And science needs to become less of a religion and more of a science. You know, uniformitarianism, I think, is the great lie that every single academic science builds its theories on. How could a little river cause the Grand Canyon? And if it did, then where is all the sediment that was carried away? It would have to go somewhere. It couldn't just disappear. You know, the electric universe has an answer for that, too. And, well, a lot of things got started with a company called the East India Company. It's who was paying Darwin. That should be looked into. Also, did you know electricity can immediately cause fossils? One thing they never talk about is that dinosaurs could not have lived in today's gravity. The origin of our solar system and the purple dawn of creation will be in our next episode. So I hope you join me for that one. And it's been a pleasure. Thank you.
Circuitry and the electric force connects and unifies all of nature, organising galaxies, energising stars, giving birth to planets, and on our own world controlling weather and animating biological organisms. In other words, there are no isolated islands in space. Thank you.
Michael Elner says, just look at us. Everything is backwards. Everything is upside down. Doctors destroy health. Lawyers destroy justice. Universities destroy knowledge. Governments destroy freedom. The major media destroy information. And religion destroys spirituality.
Was not gone over, and that is, what is a supernova. And I'm going to play this video by Mr. Thornhill and another one after it by Mr. Talbot. And then I'm going to give some closing thoughts, and we can move on from the sun. But I strongly recommend watching the videos that are attached down in the description, because you can't get the full story from me. I'm just trying to point it out. The connection between the past cataclysms and the universe are very important, because when you make that connection, you can just put it all together. And when you watch anything in ancient history, this puts it in a completely different context. And you know about everything that has gone down the way that I think it has through the electric universe and the purple dawn of creation. It paints a completely different picture. I know that it's the urge to personify is great, and there may very well have been beings or a higher civilization. I have no doubt in that. There was something going on there. But this paints a totally different picture of what was going on in the solar system. I really recommend watching these videos and any of the Electric Universe videos that I have in my playlist, if this topic interests you. Not even going to say anything about the face.
In an old elliptical galaxy in a region where there are no stars being born. So this raises some questions at the end of the article. It says, is this a runaway star from another star formation site? Is it a very local bit of star formation? Is it a different way for such a supernova to occur? None of these seems very likely, so we have a real puzzle. Well, the problem stems from the theory of stars themselves. In fact, the models of stars are so complex that they are non-predictive. One wag suggested you could just as easily come up with a koala bear as a star from the complexity of the theory. The other thing is that a supernova explosion is not really understood. It's a very clever model, but it's totally beyond belief. You have a star which suddenly switches off a theoretical engine at the centre, its nuclear furnace, and it suddenly implodes. So this requires the switch off to be sudden, and not only that, the implosion then has to rebound to form the explosion. Of course, this kind of model you would expect would form a spherical shell of material racing away from the star. Of But what do we see when we look at supernovae? Generally, they have an axis along which matter is ejected. So it's not spherical, the explosion. So this is another puzzle. In fact, it was June last year, it was reported that supercomputer models of supernovae failed to explode. All they did was to implode and collapse. So it's not surprising that astronomers are puzzled. This particular supernova shows a high degree of helium, which also is unexpected. So it was even suggested that perhaps this particular supernova was another type which is due to white dwarfs exceeding a certain mass and then exploding. And so they said maybe it was a collision of two white dwarfs, one of which was helium-rich. So you can see these special conditions that are being introduced in order to try and explain this supernova. Now, it's just a couple of years ago that I had published in the IEEE Transactions on Plasma Science my explanation of supernova 1987A, which shows structure. It showed 3 rings which were centered on an axis through the star, and these rings were made of bright beads. The one nearest the star, encircling where the star was, were very bright, and those further away were dimmer. But this kind of structure is just not explained by any theory of an exploding star.
Much of the strange and encumbered reasoning behind the standard supernova theory may be resolved if a supernova is reinterpreted as an electrical discharge.
In the electric universe model of stars, the complex chemistry to produce the heavy elements inside the star is unnecessary in a supernova. The idea is, of course, that there are populations of stars, and the first population of stars exploded and threw all of the heavier elements out into space where they were collected to make the second population of stars. Now, this is a very messy and inefficient way of producing the stars that we see in our own galaxy, for instance. Also, wherever you look, astronomers are finding anomalies in chemical compositions of stars that shouldn't be there. They're the wrong age, the wrong population. Recently, looking at globular clusters, they've been puzzled by the chemical composition of those stars because it was thought they must have all been produced at the same time in the same event, and yet they're finding compositions which don't fit that picture. In the electric universe, all stars produce heavy elements at their surface, in their photospheres, where strong electrical discharge activity is taking place. And of course, on Earth in the laboratory, this is exactly the way we produce isotopes and heavier elements. In the laboratory is by electrical power applied to accelerators. So there's nothing mysterious there. The standard model, on the other hand, requires purely theoretical and untestable things to be going on unseen inside stars. When it comes to star exploding, the electrical model is simplicity itself, and it doesn't require the star to be of any particular age because in the electrical model, of course, electrical power is supplied to all stars and is the source of their light and heat and the radiation from them. Now, Hans Alfvén pointed out that the circuits in space also include what are called double layers, where charge is separated across a very small region of space. Those double layers can act like a switch, and if that switch is thrown, then the circuit is broken and all of the energy stored in the magnetic fields of that circuit, which can extend far beyond the star into the galaxy itself, is concentrated on that double layer, that switch. And that switch can actually be at the surface of a star. So a supernova explosion is purely an electrical explosion. It's the kind of thing that has been photographed, and you can see on YouTube, when high voltage transmission power lines, the circuit is opened at an inappropriate time and a huge arc stretches between the two electrodes as they separate. So you could say that what you're looking at in a supernova explosion is the opening of a stellar switch when that star suddenly brightens to the point where it can outshine all of the rest of the stars in that galaxy.
For continuous news from the electric universe, stay tuned to thunderbolts.info.
The most critical test of the electric comet came on July 4th, 2005. That That was when NASA's Deep Impact probe fired an 800-pound copper projectile at the nucleus of comet Tempel 1. Cameras on the probe recorded the event, and even the projectile itself contained a camera to transmit data up to the moment of impact. As early as 2001, looking ahead to this event, electrical theorist Wallace Thornhill began anticipating the surprises in store for comet science. On the evening of July 3, 2005, the day before the encounter, the Thunderbolt's website published the predictions of Thornhill and his colleagues. These predictions would clearly contrast the standard and the electric comet models. As the Deep Impact probe approached Tempel 1, key NASA figures gathered in the control room. The comet was racing toward the probe at some 23,000 miles per hour when the probe launched its copper impactor toward the nucleus. If the comet was electrically charged, how would the electronics of the impactor respond to the electric field? Through most of its journey, the impactor's signal was clear, but in the final seconds, the signal was indeed disrupted. This apparent electrical disturbance was not all that Thornhill predicted. He also anticipated an advanced flash ahead of the projectile's impact, a uniquely electrical event. This is exactly what occurred. And the advanced flash left NASA scientists scratching their heads. NASA investigators were well aware of the kinetics of impact explosions. But would the projectile be striking a solid icy surface or a more loose aggregation of snowy fluff? They did not consider the electrical energy of the comet, but Thornhill had long predicted the explosion would be greater than any NASA scientist envisioned. It seems that the spectacular explosion that followed the impact was the greatest surprise. Every scientist viewing the live images expressed his astonishment. The scientists had expected to peer into a deep hole in a cometary dirty snowball before the Deep Impact vehicle was too far away. But the erupting cloud of silicate dust was so thick and the explosion so sustained that it completely obscured comets. No detection of Tempel 1 subsurface ice was ever reported. Nevertheless, mission scientists tell us that infrared readings did detect substantial water ice in the ejecta cloud. The enigma deserves investigation. What happened at the surface and below the surface at the moment of impact? Most NASA scientists interpreted the fast-moving cloud as vaporized silicates. The cloud was self-luminous at an estimated 1,000 to 2,000 degrees Kelvin, and the low angle of the impact and blast propelled the ejecta downrange. The infrared readings of the ejecta occurred about 3 seconds after impact, as the cloud came into the view of the infrared camera. These readings show what NASA scientists describe as a narrow beam of water. This water column was easily distinguished from the rapidly moving dust cloud and was very close to vertical directly over the impact site. That's a bizarre contrast to the trajectory of the dust cloud. How did a vertical column of water get instantaneously separated from an explosion of dust, heated to over 1,000 degrees and propelled downrange? The electric comet model offers an answer. The heated silicate cloud would be ionized, a plasma, a conductive pathway for an explosive electric discharge. The evidence indicates the discharge occurred between a negatively charged nucleus and a surrounding region of positive charge. An abundance of hydrogen ions gathered at or close to the surface of the nucleus would provide the necessary conditions for two things. First, an instantaneous electrical breakdown or discharge on impact. And second, an equally instantaneous electrochemical response to the discharge. Consider what is already known from laboratory experiments. In a condition of electrical breakdown, hydrogen ions from the solar wind, combining with the oxygen in silicates, can produce an abundance of hydroxyl and/or water. This very process has been proposed to explain the enigmatic water on the planet Mercury. According to the popular model, it's the pressurized gases of volatiles beneath the surface that explain the impressive velocities of cometary jets. As a last resort in the search for water on Temple 1, NASA scientists hope to identify the vents for its jets. The vents were never found. When viewed through the lens of standard theory, some predictions of the electric model could only appear absurd. Thornhill anticipated that the locations of the comet jets could actually shift as charge redistribution occurred on the nucleus after a significant electrical event. Confirmation of this prediction came from the Nordic Optical Telescope in La Palma, Spain. As released by the observatory, 2 images of the comet before impact and hours later tell the story emphatically. 15 hours after the blast, new jets appeared far from the location of the impact itself. The Deep Impact mission promised to give us the best images ever of a comet nucleus. On the eve of the impact, the Thunderbolts group stated the electrically predicted surface features in no uncertain terms. The surface of Temple 1 astonished the experts. Expansive mesas and steep vertical ridges did not belong on a comet, and the presence of craters sparked a debate that continues today. Fortunately, scientists had an opportunity for a second look at Temple 1. After the Stardust mission to Comet Wild 2, that probe was redirected to the object of the Deep Impact mission. Stardust was then renamed NEXT, or new exploration of Tempel 1. It would give additional views of the comet's surface. With the arrival of the next probe, old mysteries only grew more perplexing, leaving scientists to debate the contradictions of theory. Even the scalloping of mesa walls and nearly vertical ridges, something we've mentioned so often in connection with electric discharge machining, was duly noted by NASA scientists. At least 60 craters were counted, though collisions along the comet's path would be exceedingly rare if occurring at all, and the surfaces of active comets are rapidly eroded, far too rapidly to preserve a record of rare impacts across geologic timescales. In fact, most astronomers now reject explanation by impact, and that includes Michael Ahern, the principal investigator of the Deep Impact mission. What then was responsible for the pervasive cratering of the Tempel 1 surface? Laboratory experiments have shown that entire fields of craters are readily produced by electric arcs to a negatively charged surface. Nothing observed on cometary nuclei has contradicted the electrical interpretation. Here is the most fundamental question one could ask about active comets. Is electric arcing occurring at the surface? If so, should we not see this arcing where there is sufficient camera resolution? We have a good example in the energetic plumes of Jupiter's moon Io, where the sensors of the Galileo probe were saturated by apparent electric arcs, producing blotches of whiteout. A second example came with the Stardust mission and the appearance of small saturation points on the surface of comet Wild 2, but with insufficient resolution to make a definitive case for what the electrical theorists suspected. The enigmatic whiteouts on the active surface of Tempel 1 were everything the electrical theorists could have asked for. And the most prominent were placed exactly where the electric model envisions them, eroding the cliffs of mesa walls and extending the floors of numerous craters and depressions. Fortunately, the Swift satellite provided a view of the comet explosion not just in visible light, but in ultraviolet wavelengths, which often give the best pointers to electrical events. The ultraviolet emissions required temperatures of over 3,000 degrees Fahrenheit. The temperatures of the blast will explain why the initial eruption saturated the sensors on the Deep Impact probe. Calculations based on pixel saturation indicated a minimum initial temperature of the flash at almost 6,000 degrees Fahrenheit. Though saturation means the temperature could have been much higher. The first purpose of the Deep Impact mission was to excavate the envisioned subsurface water ice. But electrical theorists have consistently predicted little or no water on most comet nuclei. Nothing approaching the expected levels of water was detected in the exploding cloud. A lack or absence of volatiles can only mean that something is fundamentally wrong in standard comet theory.
Comets are supposed to be dirty snowballs. That's what they still teach in school. That don't look like no dirty snowball to me. That's an awful rocky looking snowball. And if it was a snowball, how long would it last when it reached close to the sun? Seriously, just amazing that Mr. Thornhill made this prediction in 2001. That was 16 years ago. And have we ever heard anything about it? I didn't. I don't think any news channel carried it. I didn't even know that there was such a thing as an electric universe 2 years ago when I stumbled on it. And it wasn't easy to find until one day that I searched electricity in space. Often wondered, where does electricity come from? Does it have a main source? And here Mr. Thornhill makes this prediction of what's going to happen when this 800-pound copper probe hit this comet, and everything he predicted came true. But yet the NASA scientists were scratching their heads. And they predicted it was just going to be collision, and a bunch of ice or debris would come out and it would leave a giant crater. In other words, that it was just going to be kinetic. It wasn't going to be any electrical or anything like that. And yet they used copper, which is the most conductive metal for electricity. So that's kind of an enigma there. I mean, they could have used something cheaper than copper. It's kind of strange. It almost gives a sign that they really know, but they're keeping it from the plebes. But I can't prove that. Kudos to Mr. Thornhill for just being right. As a matter of fact, since I've been studying this subject, I don't think he's been wrong about one thing yet. And that just signifies even more that mainstream has gone astray. And for them to remain obtuse to the whole electric universe is just ridiculous from my perspective. First, imagine where this world would be if we didn't have electricity, if there were no electricity. I think Nikola Tesla knew this, among many other things. I think he is one of the greatest geniuses that the human race has ever produced. I have always thought, why do they not teach us about Tesla in school? I think the first time I ever heard the name was from a rock group from the 80s, and then it slowly but surely unraveled as to who he really was. Why was he cast as the evil scientist in Superman comics? The genius of Tesla is that he took the schematics from nature and brought it to Earth in the form of alternating current. I think that's just amazingly genius. He was trying to prevent wars with his inventions, but he knew that humans would twist them into being able to create wars with them. And, a lot of his stuff was plundered. For all we know, they could be using his inventions right now. I mean, we're still using the alternating current system that he devised. Rockets going into space.
Right.
And NASA is not doing space anymore. Well, who is? When was the last time you ever heard of a scientist who worked for the benefit of mankind? We're still running on early 1900s technology. But the whole idea of a paradigm even existing is just moronic. And all that really serves to do is shackle investigation, which is the case in every single science. Truth be told, the whole uniformitarian paradigm exists and has existed for only one reason: to hide the truth. For reasons unknown, the major sciences are seemingly in collusion. The Royal Society governs everything. The rabbit hole goes so deep there's no telling where it leads to. But it is refreshing that they are all being challenged. My oldest son coined a term. He calls it confabulational subterfuge. I think that's pretty good. One has to just research and grow on their own at this point. Teach our kids to have an open mind and do not accept the teachings of authority as truth. Do your own research and draw your conclusions. But in the meantime, you have to just play their game to be able to get the credentials you need in life. How did things get so messed up? And why? That is one of the reasons I love baseball so much. Because when you're between the lines, it's true. There's no lying or no paradigms. Why intelligent human beings would allow themselves to be marginalized by a paradigm is just beyond me. That just, I don't know, it just defeats the whole purpose of science. You know, we're never going to grow if we just keep this paradigm in the way. That's like building a brick wall between you and the place you want to be. Uniformitarianism is the biggest lie ever perpetrated on the people of the world. I don't know, maybe it's all so that they can put on a suit every day and go to work and get a paycheck. Millions of dollars are given to people who follow the paradigm, and nothing is given to people who don't. Well, that says it all right there. But there's a growing number of people that want to know the truth. Our history is not what we've been taught. And this world is not 4.5 billion years old. I think that's pretty clear. So, all we can really do is just keep trying to research the truth and find out for ourselves. At this point, the people that sit on the top, the gatekeepers of mainstream science, they are not intellectually moral. They have no integrity. They've sold it. And that is sad. Come to think of it, we still live like we did in 1975. The only difference is now we have the internet. It's a wonder to me that it's even allowed. But at least we still have the ability to freely discuss these things. That hasn't been taken away from us. And that's a good thing. It just might start a revolution in science. I hope so. The changes that would come from it are just
sex and troll
boggles the mind. Everything would have to be replaced and changed. And that might be a major reason why it's not. Then, of course, there's the question of what would happen to religion. And that's a big what if. Mainstream is just, it knows no bounds and it has no end. Hopefully one day the paradigm will change. But it has begun. The early 21st century just might be a period of history known as the beginning of the revolution in science.
That the sons have to rise up to kill, creating primal guilt, the original sin. But perhaps Freud was on to the subject but not got it quite correct. Perhaps it was the father, the Atlantean fathers, that caused the psychosis. And in fact, if we look at our human fears and phobias, it might make more sense to think of them rather as psychological phobias and fears, but that their origin may be physiological. For why is it that we're scared of thunder and lightning, and of darkness and caves and hollow places? We have fear of water, we have fear of heights, of loneliness, of insects and certain other animals, and of enclosed spaces, and even paranoia against foreigners. And it's always put down to us by the psychologists that these are psychological fears. They just came about. So a man's fear of the ocean, that deep fear, that just came about psychologically. What? From a Homo sapien that's meant to have existed on the planet with oceans for perhaps millennia? Why would you have such an irrational fear? But wouldn't you have that fear if you racially encoded into your DNA, encoded into your racial memory, saw the whole earth torn apart, visited by unimaginable ravages, and it was in a historical blink of the eye? Such events are written in our genetic memory, and that is the origin of all these fears and phobias. They are physiologically based, not psychological.
It's like they all got together and said, okay, we're going to teach this here subject. And in order to be able to do it, we're all going to be on the same page, and we got to have this, this, and this to put it in place. And thus uniformitarianism was born. And nobody can step outside of the paradigm.
That, please. Your primitive intellect wouldn't understand alloys and compositions and things with molecular structures in the...
Paradigm to me is like, if I'm 10 years old and I make a plan for my life, that I have to stick to that plan to the letter, even though I'm going to be learning so much more down the road. And when I'm 35, I'm going to know a lot more than I knew when I was 10, but I still have to live by those rules that I set when I was 10. See, it's wacky. It doesn't make any sense. I mean, humans are so far above that, and yet we have it. We're like the kids that got thrown in the basement, and we only get to know what they decide to tell us. That stinks. It really does. I mean, I'm a spiritual person, but I'm not religious. Religion takes the spirit out of it. That just introduces dogma and rules. One doesn't need rules to be spiritual.
Anybody in the chat? Learned about the electric universe, man, I was gung ho. I really was. I think I watched every video over the course of 2 weeks. somewhere down the line, someone's going to have to get it done. Just like when the 2,000-year-long battalion system got replaced by another one we're in now. That one will be replaced eventually. This one. It'll be on the right track. Because it affects everything, including medicine, and especially medicine. Live longer lives, healthier. All right, I'm coming out.
Michael Elner says, just look at us. Everything is backwards. Everything is upside down. Doctors destroy health. Lawyers destroy justice. Universities destroy knowledge. Governments destroy freedom. The major media destroy information. And religion destroys spirituality.
Yes, indeed. Religion, yeah, that's give 10% and give on to Caesar what is Caesar's. The video's too loud. Can't hear music on video is too loud. What is
No,
that?
that was my my volume was turned down.
Oh.
It was turned down.
Oh,
But
hey, Polly girl, what's up?
yeah. So I just now I just turned the sound off on the video since it's just that, so I can hear you talking.
So is Bob Hall like thugging everybody in there? No, I'm the misfit here. Thanks for this incredible well, all right. All right, now I have to say thank you. Chuck Norris. Oh, my God. Did you know that Chuck Norris doesn't do push-ups? He pushes the earth up and down. Did you remember the Chuck Norris jokes? Circlic. Paulie, what do you think about the electric universe? We never really chatted about it. Are you down with it, or what?
Are you talking to
you?
Oh, me, of course you know I am.
Okay.
I
said
just,
someone made a comment. So you don't talk to Polly Girl about the electric universe enough, so I wanted to make sure I do.
Oh.
So you do think it's true then?
Yeah, that's what it is.
Absolutely.
Period. That is what it is. There's no other choice.
I mean, how many more times do we have to prove it?
I mean, just in the videos that you were showing, I mean, they stand there and they just point these things out. It's like, this is what they said it was, but this is what we said it was. And then they went off and did this experiment, and we found out that we were right. Mm-hmm. And they know, they have to know.
Yeah. I like how many times you hear in regular science how they're shocked or they're surprised. It's like almost on a daily basis.
Well, it's all about money. They have to keep to their, changing the way things work that's like a major, huge deal.
That's right.
And so the only way really to get that changed is to install that into young people, into kids. Teach them that.
Yes, and the one thing that I find a little troubling in the videos that I watch when Wall's giving a presentation is you don't see very many young people in the crowd. And that, sure, older people are, by the time you get a certain age, you're smart enough to be able to say, wait a minute, that's bunk, But I'd like to see 18 and 19-year-olds. That's the future,
Well, I think, they're at that, they're indoctrinated to it. And I think,
I'll turn my mic up. Someone said they can't hear me. This microphone that I got is
that's better.
Cluster. Is that better?
That's much better.
Oh, good. Okay.
I think it's for everybody else too. But
am I blowing everybody away now? I don't know. Let me see.
No, it sounds really good.
Oh, okay. That's cool. I just got to be closer to the mic and have it turned up. Yeah.
Yeah.
This mic, man, when I'm doing an audio right now for Chapter 3, I'm almost finished, but man, it picks up every little sound, and I hate smacking. I just can't stand it.
Well, you can turn that.
It picks up every little
Well, you can turn that off. I mean, you can turn your sound, what it picks up.
Yeah, well, I have to use a gate. Yeah, that's what I do. But still comes through. But it's okay. Editing is probably the toughest job. Editing the audio is probably the toughest job next to building the video. But I found that the better I read it, the less I have to edit, the quicker it goes.
There you go.
Yeah, so it's good to read it through once and then read it again instead of just reading it cold.
I mean, if you think about all the things you've read audio, I mean, you've done audio books basically,
Yeah.
really.
And I thought about doing a whole book. I was like Worlds or something, but man, I think it would take me probably a month. That's a lot. Doing all those chapters.
Yeah.
That's probably like a
But if you think about it,
10-hour book.
you've read different chapters from the book.
Oh, many. Yeah, I've read many.
So I mean, you've almost, you haven't done the whole thing, but you're getting close to at least half of it.
No, I'm still. I out of respect, I didn't want to do the whole book. I just wanted to do salt, like salt and pepper it, because I didn't want who would want to buy it then. I mean, I didn't want to interfere with sales.
Oh, yeah.
That's why I didn't do it. And I know now pretty much it's in the public domain, And once it's in the public domain, it's free for the public.
Yeah, and I love audiobooks. I do so much better if someone else is reading it. I mean, I've always had this problem of comprehending. Like I usually have to read something more than once. To comprehend it.
Sure,
I mean, even though I'm trying to comprehend it while I'm reading it, I still don't. It's like a dyslexia thing or something. I don't know.
Can you hear me better, Meredith? Yes, I know what you're saying. I do it too. I'll read something, and you know what? When I took a course at the Recording Institute of Detroit because I wanted to get to know the recording business. So the first thought for me, I was young, was to take these classes, and at that time, my company, I worked for a major auto company, paid for it. It was like $750 or something, and they paid for it. My benefits were rocking back then. And they slowly whittled them down, but they stopped doing that. But when they were doing it, I took full advantage. So I went to class, and I learned so much about recording there. And I forgot my point.
Oh, there's total art to it. I mean, it's just too much going on there for me.
I wanted to get to the point, but it took too long. It's okay.
There's other people in Discord. There's the usual people.
Yeah, I learned a lot about sound anyway. And it's just another form of electricity.
Right. That's right. I was listening to binaural beat.
Yeah.
That frequencies for that healing frequencies or whatever.
Yeah.
And I've been doing that for a while, and I mean, but they have so many variables now on YouTube, or all the different, specific frequencies for specific things. And check it out. A long time ago, I discovered these frequency things, and it was change the color of your eyes, and depend upon what frequency you picked, you could change them to green or blue or brown or whatever. So I went, because I have hazel eyes, but they're kind of, I don't know, I have a weird color of eyes.
My son Nathan's eyes are hazel. I have green eyes.
But I've always had green eyes, like khaki green. And then I don't know, something happened. I got older, and they kind of turned where they're kind of, it's a really weird kind of a turquoise color.
Oh,
it's
wow,
it's a weird color. And one day I was like looking in the mirrors, like looking, and I was like, what happened to my eyes? They're not green anymore. And I thought that was really weird. But anyway, and they've been this kind of weird color, and it's not like it's
proximity,
weird, but it's interesting. But I just thought, I've always wanted to have blue eyes.
Well,
And
so you're saying by listening to these binaural beats, it would change your eye color? Come on.
it did.
It
It did.
Well, shoot.
It did. Not right. You have to do it. It doesn't happen right off the bat, but you listen and listen like every day.
I want
and
turquoise eyes.
And I could feel it in my eyes. And I'm not one of these people. I'm skeptical about everything. So, and I thought, well, it doesn't hurt to just, listen to the thing. You just have to listen to it. You don't have to, focus or meditate. You just listen, do something and listen to it. And anyway, and because, from going from the color eyes that I have to blue, that is a definite, you can't like go and look in the mirror and go, oh, well, I'm not sure if it's blue. You're either green or blue. So,
I'm gonna have to look into that. That sounds weird.
And it doesn't last. It doesn't last that long. It stayed that way for about a week.
Except me. Yeah.
So
I'm reading chat.
Yeah, it stayed that way for about a week. But anyway,
yes, she does.
But it was fun. It was fun to do that, and
I'm going to turn myself up. Hold on.
Am I too loud?
No.
Am I too loud?
Well, not to me, you're not, but to them. Let me see. Where are you at? Where's
it all depends upon.
I'll turn your volume down.
Their volume is on their.
You were at 120%. Now you're at 100%. So I've turned you down.
Oh, you have control over my video of the.
Yes, I do. I just right-click on your name and I got your volume there.
Oh wow!
But when I right-click on my own name, I can't control my own volume. That makes me mad. So I'm going to have to go into settings.
How weird.
And voice and video, input volume, output volume. Okay, I'm going to crank that up. There, now that should be loud. Is that loud?
It's fine for me. If I can't hear you, I just turn up my own speakers on my
computer. Is it
computer.
louder now? Am I louder now?
Yes.
Okay. I hate it when I'm not. I don't like to say it. I do not like it when I'm not loud enough. And I irritated at myself when I listen. I'm going, why am I so low?
Well, yeah. And if you don't have like a little one of those little mics that you can clip on, so it stays next to your your mouth. And if you're busy talking and doing things, and you kind of get away from your mic, then
you're welcome.
You can always tell when someone's doing that. But people tell me they can't hear me, so that's why I have my mouth basically almost on top of the mic.
It's OBS, because when I'm on a Skype call with Grouch or with Ted or with Ramon, our voices are equal. But when I get on OBS is when I have the problem. It's got to be OBS.
So OBS is that's what you use for
streaming software.
Is that a separate program from? Because I was looking in on ways that you could get yours, to have a better, more consistent sound because you're having,
you see, I've employed a compressor. Let me see if it's on. It might not be on. But when I played the music the other day, I had it on, and man, oh man, I ruined it. It was way too loud. Okay.
Yeah, okay.
So now I go to, what is it again? Settings? Oh my goodness. Somewhere I can add it, but I have to, I know how to do it. Right here. Okay. No, that's not it.
It's like these programs are.
Wait a second here. Man, I'm going to have to watch that video again. I forgot how to do it.
Because I went looking for ways of helping you with your, consistency, your video and your output and stuff, with memory and you're having your hard drives full and stuff.
Oh,
what
goodness.
you there.
Yeah. Well,
and I didn't know what you're using.
What happened to me recently, right?
No. What?
I got a complete expansion disc wiped out.
Uh-oh.
I don't know how it happened. It says basically this is what it says when I plug it in now. 3 terabytes unallocated. Is that 3 terabytes of space unallocated or 3 terabytes of memory unallocated? Because that's about how many I had in there.
It's the same thing. So it sounds to me
like
it sounds like the partition table is corrupted.
Well, maybe. See, I asked you for help, but you were not available. So maybe you can help me later on after the show. Maybe you can help me recoup that.
Yeah. Because I mean, don't think that it's lost. The information is on there.
And that would be, maybe we should record it because that could be help for someone else who's having the similar problem. Because Ted told me he read that a lot of Seagate expansion disk owners are saying the same thing.
So it's Seagate. What you have is a Seagate?
Yes.
Okay. Yeah, and it depends upon
about that stuff. You're the guru.
Yeah, I do know about that. I do.
Oh, you know what? I'm going to play a little tease for everybody. I've been working hard on Chapter 3, and I thought maybe I'd give everybody about a 5-minute tease. It's pretty good. It's pretty rootin' tootin'. And it's gonna... Okay, what are you gonna do? I'm getting the wheel right now. I don't know. I might not be doing that. Okay, let's see. I think I can. I got it right. Where did I save it at? I saved it at... Yeah, I saved it in that folder. Okay. Okay, yeah, I can do it. I'm going to send it over to Windows Media Player as soon as I find it. There it is. And I think I'll do a little bit in the middle of part 2 because it's in 2 parts. Maybe it's going to be 3, actually. It's long, 48-page chapter. That's not a short chapter. All right. Come on, show up. Why aren't you showing up? Because my name's Greg. Is that what it is? Oh, there it is. Oh, I wonder how that happened. Okay. Well, here we go. A little tease.
Battle in the sky. At the same time that the seas were heaped up in immense tides, a pageant went on in the sky, which presented itself to the horrified onlookers on Earth as a gigantic battle, because this battle was seen from almost all parts of the world, and because it impressed itself very strongly upon the imagination of the peoples. It can be reconstructed in some detail. When the Earth passed through the gases, dust, and meteorites of the tail of the comet, it disturbed in rotation. It proceeded on a distorted orbit. Emerging from the darkness, the eastern hemisphere faced the head of the comet. This head, only shortly before, had passed close to the sun and was in a state of incandescence. The night the great earthquake shook the globe was, according to rabbinical literature, as bright as the day of summer solstice. Because of the proximity of the Earth, the comet left its own orbit and for a while followed the orbit of the Earth. The great ball of the comet retreated, then again approached the Earth, shrouded in a dark column of gases, which looked like a pillar of smoke. During the day and of fire at night, and the Earth once more passed through the atmosphere of the comet, this time at its neck. This stage was accompanied by violent and incessant electrical discharges between the atmosphere of the tail and the terrestrial atmosphere. There was an interval of about 6 days between these two close approaches. Emerging from the gases of the comet, the Earth seems to have changed the direction of its rotation, and the pillar of smoke moved to the opposite horizon. The column looked like a gigantic moving serpent. When the tidal waves rose to their highest point, and the seas were torn apart, a tremendous spark flew between the Earth and the globe of the comet, which instantly pushed down the miles-high billows. Meanwhile, the tail of the comet and its head, moving, having become entangled with each other by their close contact with the Earth, exchanged violent discharges of electricity. It looked like a battle between the brilliant globe and the dark column of smoke. In the exchange of electrical potentials, the tail and the head were attracted one to the other and repelled one from the other. From the serpent-like tail, extensions grew, and it lost the form of a column. It looked now like a furious animal with legs and with many heads. The discharges tore the column to pieces, a process that was accompanied by rain of meteorites upon the earth. It appeared as though the monster were defeated by the brilliant globe and buried in the sea. Wherever the meteorites fell, gases of the tail subsequently enveloped the earth, the globe of the comet, which lost a large portion of its atmosphere as well. As much of its electrical potential withdrew from the earth, but did not break away from its attraction. Apparently, after a 6-week interval, the distance between the earth and the globe of the comet again diminished. This new approach of the globe could not be readily observed because the earth was shrouded in clouds of dust left by the comet on its former approach, as well as by dust ejected by the volcanoes. After renewed discharges, the comet and the earth parted. This behavior of the comet is of great importance in problems of celestial mechanics, that a comet encountering a planet can become entangled and drawn away from its own path, forced into a new course, and finally liberated from the influence of the planet, is proved by the case of Lexell's comet, which in 1767 was captured by Jupiter and its moons. Not until 1779 did it free itself from the entanglement, a phenomenon that has not been observed in modern times, as an electrical discharge between a planet and a comet, and also between the head of the comet and its trailing part. The events in the sky were viewed by the peoples of the world as a fight between an evil monster in the form of a serpent and the light god, who engaged the monster in battle and thus saved the world. The tail of the comet, leaping back and forth under the discharges of the flaming globe, was regarded as a separate body, inimical to the globe of the comet. A full survey of the religious and folklore motifs which mirror this event would require more space than is at my disposal here. It is difficult to find a people or tribe on the earth that does not have the same motif at the very focus of its religious beliefs. Since the descriptions of
Five-minute tease. It's coming. Hee hee.
Well, 30 seconds. I can hear you. You're still in there. I mean, so is it Anusa. I still want to call him Ed. Yeah, but they never say anything. And we're Shockwave. I mean, Shockwave.
He's got the right accent, though, hasn't he, Adusa?
Are you?
Adusa's got the right accent.
So I haven't heard that one.
There you go, see?
Well,
I'm normally half asleep at this time of day.
hasn't it been rainy and cold over there?
He must have gone back to sleep, Greg. Would you go to sleep, Doosa?
Oh, I'm back again. I was just getting massive echoes, and I seem to have. I've just shut the live stream off. I think that's the thing. So.
Well, I said
USA, that'll do. Yeah, Ed USA. Doosa.
And Grouch, aren't you from Britain too?
No. Australia.
Australia. Oh, excuse me.
Yeah, we'll forgive you. We'll forgive her.
Now you see. Well, I mean, I can tell the difference between someone from New Zealand and someone from Australia, but sometimes I can't tell the difference between someone from Australia and someone from Britain. I don't know. Yeah, well, I can. Yeah, Liverpool. Yeah, like if you're from Boston or, isn't that weird? Yeah. They speak proper English. They don't have a lot of slang. But I know that I have an accent. I'm sure to other people, and of course But do I sound? I mean, what makes me sound like a Californian? Just from me talking. I mean, how can you tell? I mean, because
it's like listening to a southerner, say Alabama or somewhere, compared to someone in yeah.
No, you don't. No, I think you sound. Well, you don't have an accent. You sound like the way I think I sound. But like if you're from Minnesota, you Minnesota, don't you know? And I used to say when I lived in Washington State, I started talking how these weird things. I was sort of picking up the Canadian thing, but I mean, I don't know. I was talking to somebody that was a language expert person or whatever, and they were saying that out of all the English, all the different, slang or whatever that the people have that speak English, California has, or people considered from California, or maybe it's like you. I mean, I can't say that there's people in the United States that have Southern accents, and then there's the, Maine, and they talk weird. But I mean, people like just your normal American doesn't have it. Put a slang on the words. There's no slang on the words. So we speak more proper English than anybody else. That's what this guy was saying. Well, yeah,
that's because you've had television longer. That's because you've had television longer, and they've corrupted you.
Oh. But I mean, Huh.
Yes, we are slightly different down south to someone in Queensland, but we get like they talk quite a little different to us, a bit slower, sort of.
Or maybe because you sound like Crocodile Dundee.
Oh, righto.
You know that.
Yeah, well, you see, he was from Sydney. He was from Sydney.
Is that
right?
Southern? That's
well, that's sort of halfway. But when you get up towards the top of Queensland, Cairns, and them areas, well, they are different again. But like those areas were isolated technically for a long time. It was their own sort of area. If you get one.
Yeah.
Yeah. Queensland.
Yeah.
Queensland. Yeah. So no.
So you really did that? Really? Sure, when he got killed, I'm sure that he could have taken more safety precautions, I guess. I
think he overestimated himself with a stingray, and it was just sort of bad luck that it got him. Where it got him, so basically, its sting went straight into his heart.
Oh my God! Why the heart?
Oh, really? Well, that's just what got him.
Oh my God! So the stinger, it's like a dagger.
Yeah, but they're fairly poisonous too.
So was he swimming with it, or?
Yeah, that was what he was doing. That's what he was doing. He was making a documentary explaining how, happy these animals were to be friendly with humans. Because that's what they sort of try and put across when they're laughing.
But he got too close or whatever to it, and the thing went, no, go away, and he whipped him with his...
Yeah. I think that's about it.
Wow, yeah. They don't lose their stinger. That's because the bee stinger it's like a bulb on the tip. Because I know I got stung by one time, and his butt was hanging there with But bumblebees, I guess they do have stingers, but they do. Yeah, we have a red bumblebee. I was really surprised when he died.
Man, when am I going to
Is it?
My mic wasn't on.
Oh, we've
yes,
so the people on YouTube.
We can hear you.
So the people on YouTube have been sitting there in quiet.
Yeah, sitting there waiting. Man, I am such a moron. I'm going to get to the next thing. I'm going to do Purple Dawn or what do you guys want to see?
What? Yeah, that's a good one.
Does anybody have a... We were
Purple
talking about...
Dawn's a good one.
Is it going to be a long video or a short one?
Well, I don't know. I'm asking folks what they want to see. So it could be a long one, could be a short one. Do you want to see Purple Dawn? Because that would be 4. That would be the next one in line.
Let's look in the chat room and see what people want.
Yeah, that's what I'm waiting for someone to say something. But everybody's just kind of chilling right now.
Oh, I thought you spoke bloke.
It's only Bob and Meredith that are chatting. The rest are patiently waiting. For my dumb freaking...
sometimes.
God, I can't believe that.
What did you do? I mean, I can
gotta
hear...
remember to turn my mic on.
So they can hear
You know what? I think I'm going to leave it on and go...
He turns the mic off because Greg turns it off on Discord, so that way then if he says something, it doesn't necessarily go back through in there.
If I turn my mic off...
So what we've got to do is...
Never turns it off in Discord. He always has it wiped.
Right.
No, that's for us to communicate with him.
Yes.
But that won't. But then that won't go to Discord if he talks to you. So what we've got to do is remember to say, "Hey, you got that mic on?"
I got my mic on now.
Yeah, all right.
In the morning, Greg. I missed that guy. He was a genuine good bloke. Yes, the guy, Steve Irwin. Yes, he was. He was a good guy.
Well, I used to like some of the things he did with snakes. There's no way known you could get me playing around with snakes like he did.
Oh, no.
Yeah, he was.
You know,
nuh-uh.
Some of those snakes he played around with, there's no way known because like one whack from them and you're pretty sick.
No problem.
And he'd have them as calm as he'd get them as calm as a cucumber.
Yeah. He was fearless. Guy was.
But he had a way with all animals, really.
Mm-hmm.
But the animals, there's a lot of volatile, deadly animals in Australia. I mean, like, not a lot, but I mean, bugs and stuff, right? Don't you have frogs that are really bad? Some killer.
Yeah, we have a good few. We have a good few there that it's like if you get bit by them, you can be in a bad way.
Yeah.
But you don't sort of. It's a bit like where you live. You got your different things, and you don't sort of live your life worrying about it.
I mean, we're
yeah. So, fun. Where you going?
You guys are talking while I'm looking for the next video. I think I'll do. Let's do. Cosmology for Layman Part 5. Purple Dawn Part 2.
Yeah, Purple Dawn.
Part 2.
Yeah.
I like Purple Dawn. That's
right.
You guys want... Yeah, this is a 32-minute video. It's called Purple Dawn Chronology Part 1. I saved it. Let's check it out.
Okay, that'll be interesting.
Okay, go for it. We'll go into silent mode.
Okie dokie.
Bye, Greg.
Me too.
I enjoyed the chronology part of the last video quite a bit, so I decided to go back and go through it a little bit more methodically and share it. Here it is. Okay, we have chaotic debris, Purple Dawn, carbon nanoparticles in stratosphere, extended period of shadow under Purple Dawn, Proto-Saturn, coldest climate Earth has ever known, darkest before creation in the mytho-historical record. Maydu cosmology, Hopi cosmology, Hawaiian cosmology, Hindu. Oh my goodness, look at that word. Oh yeah, that's that Hindu piece right here. Brihad, Dharanaka, Prasad. There's a mouthful. Illustrated bark books of Mesoamerica. Maori cosmology. Maori cosmology. Hebrew Genesis 1:2. The earth had become a desolate ruin.
Zohar and Psalm 18:12, Psalm 97:2, Isaiah 45:7. I know you might be inquiring why so much religious material. Well, in a lot of cases, the Bible is the only source of reference. The scribe who was writing that was living in those times and writing about it and equating it all to God, Artistic representation, Mary the Younger Dryas. In the beginning, someone left a comment, that was nice. In the beginning, he created Elohim, the heavens and the earth. And the earth, she became chaos and vacancy and darkness over faces of abyss and spirit of Elohim vibrating over surfaces of the waters. Every version of Genesis that I hear or read, it seems different. Kind of the same, but different. Which one is true? That's the thing. You're dependent on someone else's interpretation. Interpretations can be molded. But I think when they were writing about the times, I don't know why they would have any reason to lie about that. Now, Holocene extinction, deathly environmental conditions, frozen tsunami tides of large flora and fauna, probably dead, just floating around. Imagine how that would have been. Earth increases in charge and mass. Large-eyed mud dwellers. Clovis culture incinerated in North America. We talked about that. Anxiety of soggy, bedarkened survivors. Absolutely. Just think, man. What was the name of that Alice Cooper song? Oh my goodness. It's been so long I can't remember. Raped and Freezing? Yeah. Earth's descent from lateral to subpolar. Now here, I don't know if it would have caused a cataclysm, but anytime the Earth is going to displace from where it's at and begin a new rotation, I would assume so. So that was another one. Shuri, 1912, Saturn Planetary System, Proto-Saturn Nebula. Earth begins subpolar rotation. Chaotic clouds of debris. Cardona, 1982, Proto-Saturn Nebula and spiral approach to the Sun. Yes, it made a spiral approach. Thornhill, 1998 and Company. Cathode flaring of red Saturn protostar. The comet-like acceleration towards the Sun. With the Earth in toto, probably. For Cook, Earth enters outer envelope of Saturn's plasma sphere. Earth's spiral descent through plasma plumes of the polar configuration, flaring and instabilities of the Pirac column at double layers. And we got some pictures to look at here. There's Earth, the Pirac column, plasma stream. Intense aurora plasma column as determined from extensive GPS survey of petroglyphs worldwide. Looking at petroglyphs and breaking them, putting them all kind of into what they seem the most. That's amazing right there. So planets were encased in that. Huh? Just think, towering over their heads. What would you think of it? Pretty crazy looking. Conical inflow of a current conducting plasma column. The flow is from top to bottom with striations in the body of the column, and the beginning of a plasma feature at top center. These experimental photographs pertain to a 5MV3MA plasma. Ceremonial cup from Ica, Nazca, Peru. Lightning Brothers, Australia. I always dug those guys. Pretty hip. Two-headed figurine from the Kaone. And that's the pictures there. This here, video reconstruction, looking south. Oh, that's mighty cool. I've seen it before. It's neat. Hello. Make it smaller. Video reconstruction looking south as electron streamers trail away toward the ball plasmoids of the Peratt column. Animation by Richard Smith. That's a pretty good job. Electron streamers rush past Earth, joining the Peratt column below, the Saturn system above. Yeah, just encased like a little catacomb. Cocoon. That's what I meant to say. Like a little cocoon. Polygraph pictures of what this formation must have looked like or something. Yeah, that's the Squatter Man. We know that. I got one of those t-shirts. It's pretty cool. Depiction of an intense aurora funnel. Figures showed both down flowing and upflowing Brooklyn currents contain two concentric sheets. Oblique upward view, right side view, barely discernible at the lower center are the Z-pinch instabilities. Yeah, that's like that supernova in 1987. Okay, let's see what this is. 3 flares of the Peratt column. Blindingly bright ball plasmoids. Genesis 1-3 Maori cosmology, Hawaiian cosmology, Nazca artifacts, Göbekli Tepe architecture, Levantine Neolithic masks. Oh yeah, those masks are cool. I've always been drawn to them. Wouldn't mind getting a couple, you know, for the living room. I'm serious. Be a cool piece of art to have in your house, you know. I like to be a little eclectic. Oh my, man, these words, you know, they're just so foreign to me.
Ometepe.
Ometepe Island head dressing figures. Novelli Cordy artifacts. Columbia River headdress faces. Nazca headdress figures. Land of Fire. Heart of the Earth. Heart of the Sky. Chinese cosmology. There's just so much here, man. 3 Fates. Colombo River. Standing or squatting, luminous humanoid, Hebrew cosmology. The first one was 3 flares of the Peratt column. I see, that's pretty cool. Look at that dude. He's just chilling. There's a mugshot. Man, that's pretty tall. Look at that. That's got to be really old. It looks old. fix this. Try to get it all in there for you. Ural Mountains. This must be some old wood guy they found. There's just so much of it. It's crazy. After a while, you begin to learn, oh yeah, well that's when Saturn was, when you'll start seeing things once you get to know this. It's everything had to do with this. Everything in our culture. It's amazing. Zigzag. Over there, zigzag rolling papers. And they got it from the Zigzag Devil. Artifacts. More drawings. They're looking at it. And they're drawing it there. Or doing however they do it. One thing that really amazes me is how well this stuff seems to have held up through so long a period of time. When things degrade so fast in the sun. I bought a thing to practice with baseball in the backyard, so you don't have to go to the park, And it stayed out in the backyard all summer, and the damn thing's no good anymore. It's bleached all out from being in the sun, just from being out in the sun for one summer. Just imagine, I know there's rocks with writing in them that are 20 years later, and it's embedded into the rock 20 years later, it's gone. But this stuff seems to hold up. They must have had some kind of a technique, or it was protected. And it worked like that. How can that stay like that for thousands of years? It's kind of crazy, actually, when you think about it. All this stuff, and I'd like to see it all. I guess we got to keep going to different ones. Seen that before. Oh, that's pretty hip. A lot of this work is just amazing. Taki, Aztec Mother Goddess. Okay, then we move here to 9000 BC to 8347, early Boreal Mesolithic. Jupiter and Saturn as dwarf star companions of the Sun during the Neolithic. Conventional Cook. TZO Betelgeuse, possible candidate for a brown dwarf anode inside a red giant cathode. Plasma sheath. Analogous to Proto-Saturn. So they're saying Betelgeuse might be like a Proto-Saturn with planets inside of it. That would have life. They got this myth about Betelgeuse that it's a red supergiant that's ready to go supernova at any time, or maybe it already has. I think that's all a bunch of poppycock. It's just ridiculous. Stars can't be nuclear engines. They just can't be. I think from the way it looks, anybody that has a charge could possibly become a star. I mean, the line between planet and star is getting grayer and grayer, isn't it? So Betelgeuse might be a star with life. It would reach all the way to Jupiter if it was in our solar system. So all those planets are inside that plasma sheath, orbiting or maybe staying still. I don't know. Probably orbiting, I would think. And there's the inside of Proto-Saturn, brown dwarf. What they're surmising. Proto-Saturn is a brown dwarf with a red giant plasma shell. So it's a red giant on the outside, but a brown dwarf on the inside. Aha. Incoming light.
blocked by opaque plasma sphere. That would be the sun. Archaic Axis Mundi. Talbot Cohen. I've seen that before. M87 jet, suggestive of the Herbig-Haro object, like plasma stream from Proto-Saturn. And that's a pretty good timetable here. I mean, like I said, maybe we couldn't never find out without any detail, but we got a lot of smart people on it. Like I said before, human beings are smart. They figure things out. Okay. Then we move to the early hypsothermal. Earth averaged several degrees warmer than modern day. More rainfall in subtropical regions. Ring rain. Let's take a look at this. Climactic optimum. Holocene temperatures. So it goes from way down here and starts to linger a little bit above zero here. So during Earth's subpolar orbit, we had change of season for the first time. Summer-winter conditions under the south pole of Saturn. Started to experience what it was like to have seasons. Then we get as above, so below. Neolithic cultural mimesis. Early communal settlements. Göbekli Tepe continued 9130 to 8800 BC. Neveli Kori, Keanu. Early Levantine tells 9000 to 8500. Doggerland Fishing Bank. Now you know about Doggerland, right? That just went bye-bye. It's where the English Channel is now. Man, that would be one of our worst fears, to just all of a sudden be at the bottom of the ocean or the channel. Creative novelties of Neolithic culture.
Are you kidding me?
Formative aspects of culture, language, social organization, proto-religious sentiments. Artifacts demonstrate lack of violence and warfare. The only thing that's bad about religion that I see is that other people have expectations that you must do this or else. That's the worst. That's the wrong position to take. People should be flocking to you instead of trying to get away. 3, from day to night. And after a while, you begin to learn, oh yeah, well that's when Saturn was, when you'll start seeing things once you get to know this. Everything had to do with this. Everything in our culture. It's amazing. Zigzag. Were they zigzag rolling papers? And they got it from the Zigzag Devil. Artifacts. More drawings. They're looking at it. And they're drawing it there, or doing however they do it. One thing that really amazes me is how well this stuff seems to have held up through so long a period of time. When things degrade so fast in the sun. I bought a thing to practice with, baseball in the backyard, so you don't have to go to the park, And it stayed out in the backyard all summer, and the damn thing's no good anymore. It's bleached all out from being in the sun, just from being out in the sun for one summer. Just imagine, I know there's rocks with writing in them that are 20 years later, and it's embedded into the rock 20 years later, it's gone. But this stuff seems to hold up.
They must have had some kind of a technique, or it was protected. Yeah, work like that. How can that stay like that for thousands of years? It's kind of crazy, actually, when you think about it. All this stuff, and I'd like to see it all. I guess we got to keep going to different ones. Seen that before. Oh, that's pretty hip. A lot of this work is just amazing. Taki, Aztec Mother Goddess. Okay, then we move here to 9000 BC to 8347, early Boreal Mesolithic. Jupiter and Saturn as dwarf star companions of the Sun during the Neolithic. Conventional Cook. TZO Betelgeuse, possible candidate for a brown dwarf anode inside a red giant cathode, plasma sheath. Analogous to Proto-Saturn. So they're saying Betelgeuse might be like a Proto-Saturn with planets inside of it. That would have life. You know, they got this myth about Betelgeuse that it's a red supergiant that's ready to go supernova at any time, or maybe it already has. I think that's all a bunch of poppycock. It's just ridiculous. Stars can't be nuclear engines. They just can't be. I think from the way it looks, anybody that has a charge could possibly become a star. I mean, the line between planet and star is getting grayer and grayer, isn't it? So Betelgeuse might be a star with life. It would reach all the way to Jupiter if it was in our solar system. So all those planets are inside that plasma sheath, orbiting or maybe staying still. I don't know. Probably orbiting, I would think. And there's the inside of Proto-Saturn, brown dwarf, what they're surmising. Proto-Saturn is a brown dwarf with a red giant plasma shell. So it's a red giant on the outside, but a brown dwarf on the inside. Aha. Incoming light blocked by opaque plasmasphere. That would be the sun. Archaic Axis Mundi. Talbot Cohen. I've seen that before. M87 jet, suggestive of the Herbig-Haro object, like plasma stream from Proto-Saturn. And that's a pretty good timetable here. I mean, like I said, maybe we couldn't never find out without any detail, but we got a lot of smart people on it. Like I said before, human beings are smart. They figure things out. Okay. Then we move to the early hypsothermal. Earth averaged several degrees warmer than modern day. More rainfall in subtropical regions. Ring rain. Let's take a look at this. Climactic optimum. Holocene temperatures. So it goes way down here and starts to linger a little bit above zero here. So during Earth's subpolar orbit, we had change of season for the first time. Summer-winter conditions under the south pole of Saturn. Started to experience what it was like to have seasons. then we get as above, so below. Neolithic cultural mimesis, early communal settlements, Göbekli Tepe, continued 9130 to 8800 BC. Neville Corey. Those figures they found dated 9,000 years old. Early Levantine tells 9,000 to 8,500. Doggerland Fishing Bank. Now you know about Doggerland, right? That just went bye-bye. It's where the English Channel is now. Man, that would be one of our worst fears, to just all of a sudden be at the bottom of the ocean or the channel. Creative novelties of Neolithic culture. Formative aspects of culture, language, social organization, proto-religious sentiments. Artifacts demonstrate lack of violence and warfare. The only thing that's bad about religion that I see is that other people have expectations that you must do this or else. That's the worst. That's the wrong position to take. People should be flocking to you instead of trying to get away. 3, from day to night. So this is when we first got introduced to day and night, 8347 BC. Paret column collapses, ball plasmoids depart. Mare mythos, the quiche of Maya mythos. I assume those are books of their myths. Mesoamerican cosmology, the Popol Vuh. I like to say that, the Popol Vuh. Crow cosmology, Hopi cosmology. Phoenix's triple death rebirth. Whoa. Man, I'd like to get into some of that. The Phoenix. Well, I guess we will. Phoenix's triple death rebirth. Vishnu measures the earth 3 times. Long count as end of first creation. The kilo year event. Let's find out what that is. Polar configuration now visible. Plasmasphere shrinking. Mesoamerica, Council of 6 Gods. Powers overhead in the north. Cook. Glowing stream of archaic axis Mundi. And that's the Talbot column. Vandersluis. So we'll take a look at this. 8347. That's what it looks like. We've seen that. Oh, that's a good picture. Post-glacial sea level rise under archaic skies. Metamorphic star. Dardu Cordona. That's a cool picture. Number 4, post-glacial sea level rise. Periodic flooding of northern Europe, 8,500 to 6,200. Getting closer. Former landmass of North Sea, Doggerland. That was just collapsed. Just went right there. Oh, that's suggested wetlands of Antarctica. If Earth's poles were ice-free. Yeah. So let's take a look at some of these pictures here. Reconstruction of early Neolithic Doggerland. Right there. I guess there was a little bit of a channel. And that's pretty cool. What is that? I didn't read it. NASA rendering of Antarctica's landmass. 1531 AD, or 531 if you think that the one was put there, of Antarctica, purportedly based on Egyptian maps 2,000 years older. Periodic flooding of northern Europe, 8,500 to 6,200, former landmass, North Sea, Antarctica free of ice. Post-glacial flooding prompts migration northward. Now we're at 8347 to 6200, the late Boreal, Neolithic Boreal. The winds, the Boreas. I remember there was that saying, the Hyperboreans. The Neolithic Revolution. We got pictures. Right here. Mutation of gene OCA2 produces first blue-eyed humans near the Black Sea. Earth rings, a prominent yet widely misunderstood aspect of the ancient world. It shows the firmament, the arch of night, heaven of fire, Greeks and others. Ocean of heaven, yeah, they called it the ocean of heaven. Firmament with the stars. The word Pleiage from the Pelestians and also the Palladians. Here they didn't use vowels in the ancient world. So the word Pleiage is French for beach, I think. I'm thinking that, they may think that we came from, by that name, we came from the ocean of heaven. Pillars of earth, primeval ocean, underworld. It's a good picture. Looks like some cubicles. Okay. So here we get early worldview of the ancients, waters, above and below, glow of encompassing plasmasphere, sea of space, of the Edda. I've heard that word before.
Mime.
Yeah, what he said. Of Genesis, spirit waters, ether, the firmament, equatorial rings. Abyss or deep, shadow beneath rings. Petroglyphs commemorating the Prat column. Tokens writing simple tokens as representative of Prat instabilities. This is when they were doing the firmament. They imagined. This is where the flat Earth starts to come in, when they were imagining the Earth was flat and there was a big dome. Sheol, columns of the earth, firmament in the sky. Heaven begins, bodies of light. Okay, this is Buddhist cosmology. 4 heavens of the mental bodied. 16 heavens of beings with bodies of light. 5 heavens of gods of the desire realm. 4 world guardians. Realm of desire with beings of gross form. You go down here from the joyless realm, great wailing, great darkness, up to the fire, still in the joyless realm, smoke, swamp, sand, water. thorns, gravel water, the Nagas, the Asuras, human beings and animals are here on the Earth disk. It is called the realm of desire with beings of gross form. 4 world guardians, 5 heavens of gods of the desire realm. And there's 16 heavens of beings with bodies of light. You see, I told you, we have no idea what kind of life forms are out there. There's this term called life as we know it. Things that breathe in and out. But there is nothing that says that there are not creatures that could live in space. I wouldn't doubt if there is. It's the realm of form, and then in the formless realm you have 4 heavens of the mental body. The firmament. It's that Inca cosmos. So that's what the Incas thought. Well, it would only be natural to think like that before you know what your surroundings are, till you can get far enough away to take a look at them. You know that saying, can't see the forest for the trees. Hindu cosmology, we're on the back of a giant turtle. It's the term in the firmament. It's funny, we still call it the firmament. There's the chariot of the sun. This is Norse cosmology. From the Norse, the Vikings. Must spell Jotunheim, Nephilim, so that's a Norse thing, the Nephilim. It looks like Nephilim. I have to put my, where are my glasses? They're always never where you need them. No, hell. And Hebrew cosmology it's called the Helid. It's our period, hell, it. Dragons. This guy here, this guy's fishing Midgard. Asgard. This must be where Thor and Odin live. Creatures in the sea. Navajo cosmos. Okay. That's what they pictured. Okay, that's it. And we did that Hebrew cosmology, the firmament of the sky, the sun, floodgates. Yeah, they actually thought that there were gigantic floodgates above them with doors that occasionally opened. The moon there, columns of mountains, the abyss, columns of the earth, so it was held up by columns. That's pretty good. You guys should have told me that I didn't have the screen on. I feel bad, but I sent it back some. Is anybody there? Anybody in chat?
Yeah, I'm here, Greg, but I haven't been watching the YouTube bit.
Oh, you was watching the YouTube?
Okay. No, I haven't been watching YouTube.
Ah, okay. That's all right then. What'd you think of that? Did you watch it or no?
No, I missed that.
Oh, you missed that one? Well, you were watching something else, you traitor.
No, I've got two young blokes here keeping me pretty busy.
Oh, okay. All right. You're forgiven then.
No worries. Okay, thanks. Thanks for that.
Yeah. Well, might as well get on to the. Well, you know what? We got to end this broadcast and start a new one. So please join me for the next one that I'm just going to pop on right after this.